All right, hello world. This is CS50 on Twitch. My name is Colton Ogden, and we're joined today again by CS50's Nick Wong. Nick, hello.
Hello.
Good to have you on the stream again. What are we talking about?
Always a pleasure to come back. So we're talking about CTFs. I saw some discussions in the chat, which was, what is a CTF? It's cool the fridge. You got to keep your fridges cold.
Yeah, of course,
and, kidding. That's not at all what it stands for. It stands for capture the flag, and that is non-technical. We were joking a little bit earlier that it sounds very weirdly non-technical for something that is somewhat technical. But basically, there's these kind of flags. They're basically just strings of random characters or maybe meaningful characters or phrases. They're hidden somewhere, maybe in a system or maybe as like some sort of abstract like reward for solving puzzles, and you have to go find them. So what we're doing today is a type of CTF, which is you get handed a system, and there may be some vulnerabilities or kind of like puzzles that you have to solve, and when you solve them, you get these flags, and the flags are actually, in our case, passwords to new levels. So each level is actually a user on a UNIX, on an Ubuntu system, and after we get a flag, we can use it as a password for the next level, or the next user.
You mentioned this is particularly a server-based CTF, but there are file-based versions, like Google's that they put out. And I think maybe another one that I'm missing offhand. I think Pico 2017's did have some file-based stuff to it.
Pico, I think, covers a wide range of like category where they have some like SSH interfaces. Sometimes it's just a puzzle, like just decrypt this. Some of them are like, can you explain how this works, or can you pick the right answer? Some of them are like, here's a file, can you figure out what its meaning is? And it's like a PCAP file, so you throw it through a Wireshark or something. And so I think Pico CTF does a really good job of covering a wide range of difficulties and also just types. I like to focus on the box-based ones, just because my background is a little bit more cybersecurity focused, so it tends to be focused on like a machine, what vulnerabilities it has, how do you configure it correctly, hopefully.
Hey. A lot of awesome people. So is our Skulks Cold, Asley, Tuxman, Bella Curious, and Ecstasy. I'm not sure if I'm pronouncing that one correctly. But thanks to everybody so much for tuning in. Unrelated to CTFs or anything really, content-wise, today's episode is number 50.
Hey.
And this is a CS50 show. This is CS50 on Twitch.
Yeah.
And actually, we're going to take this opportunity to announce that we're actually rebranding. So we are moving away from the name CS50 on Twitch, given that we publish or we produce our content not only for YouTube and not only for Twitch, also to Facebook and YouTube and other platforms. And so we're actually transitioning from strictly being CS50 on Twitch to being CS50 Live. And the chat window is a little bit, it looks like it's kind of blocking that out just a little bit. So I'm going to shrink that down just a little bit. But some folks might remember this from years prior where we actually had a news show. We did this back in like 2013, 2014.
It's a little before my time.
Yeah, we had a current events show. It was called CS50 Live. And David and Doug and others would come on, and I actually did a show, an episode too with a robot. We danced the Macarena actually, which is a great time.
That's wild.
But we did this show based on current events, and just given time constraints, we weren't able to really bring the show. We weren't able to do it as consistently as we wanted to. So given that we've been doing this show and it's live, and we broadcast to multiple platforms today, we're transitioning to CS50 Live.
Well, I'm happy to be a part of it.
So
thanks for being on episode 50.
Thanks for being on this episode and for being on so many episodes prior to this too.
Yeah, of course.
So, with that announcement, I guess why don't we just kind of get right into it?
Sure.
I think.
I also realized I'm wearing the.
Oh, you're wearing a CS50 shirt too.
I think this is from my freshman year too.
There's a lot of CS50 in the air, in the atmosphere.
Very CS50 like.
I can feel it. I can feel it.
In case you couldn't tell, this is CS50.
Let me go ahead and transition to what I think yours is in right now. So if I do that, we do indeed see your awesome
canonical background
shell there. Which is a remind people how again to get a shell that looks kind of like this.
Yeah, so this is a program. We'll go and find it. This is the program CMatrix, which looks like this normally. On Macs, I can pipe that to lolcat. Oh, whoops, sorry, can't type live. And it gets this beautiful rainbow color. I've found that on like Ubuntu systems, I wasn't necessarily able to get this piping effect quite right. So there is kind of a bummer with that, but if you can figure it out, let me know. I tried piping all of the like varying standard outs and standard errors to one output and see if I could get it to rainbow color it, but I'm not entirely sure how CMatrix and lolcat work on the bottom or on the back end. So, however that ended up happening, it works on Mac. So on OS X's Bash, this is fine.
It's beautiful. It's an upgrade from the default terminal.
Thank you. I agree. I'm also a huge fan of, if you look at my terminals, my Bash, it has a little kind of cute smiley face here.
Right, yeah.
Really not interesting for functionality, but if I like type a command that doesn't exist, it tells me that I had an error.
And you have a cry face, yeah.
Yeah, and it just kind of says, dude, what the heck happened? And if I go back to something that works, then I get my smiley face back. Kind of cute
Visual
little things.
feedback is an important thing.
Exactly. I just like keeping my my terminal personal, you know.
And you don't typically get a lot of very nice visual feedback with the terminal interface by default.
Not normally. A lot of times things will succeed by giving you nothing, actually.
Yeah.
And they fail by yelling at you. So it's like, I kind of like having some feedback. Oh man. Onidna? Oni
Oni now BJ. I'm not sure. Yeah.
Sorry.
That's a tough one.
Call it Oni, maybe?
Oni. We'll say Oni. Yeah.
Oni, and that way you know who we're talking about. I'm behind that virtual machine for a while. Keep asking me the link where they looked for it. Not entirely sure which virtual machine you are talking about, although my guess would be the CTF. And so there's actually a link. We short-linked it, or bit.ly'd it. So if you go to this link, there's a beautiful blog post by
I'll type it in the chat too.
Person named Charlie Guo. And he wrote this kind of like setup walkthrough on, I'll also duck underneath that, on the CTF that we're going to do today. I followed his walkthrough to set everything up, and then that's where I stopped. So definitely a good, definitely a good thing to go and follow if you want to kind of play around on your own AWS instances. We're doing all of this for free, but technically through AWS. So you're welcome to follow along if you'd like. If you want to get some cool bug bounty money from AWS, then you could try and hack into the box we're using today. We've set up a firewall that hopefully drops all traffic but ours. So if you find a way through, let us know, and then we'll tell AWS, and we'll share money, I guess.
They're going straight to Amazon. They're not telling you.
Yeah, they're not even telling us. But Amazon will know. Sarl CS tells us Oni means demon in Japanese.
This is true. This is true.
It's good to know. I don't know a whole lot of Japanese, but I'll take your word for it.
And then people are talking about CS50 Live. There's a Scratch episode that was so nice. It's been a while, but I vaguely do remember that. And then shout out to David in the chat, David J. Malin. Thanks for joining us today, everyone.
Welcome.
And then also, shout outs again for 50th episode, which obviously
cool.
Thanks to David for the support on the show. We've been able to get that far. So
really appreciate it. Yeah. All right. Well, let's hop into it. We will kind of like breeze through some of the parts that we did last time. And then we'll be on a new puzzle that neither of us have looked at or solved.
Oh, true. Yeah, for those who are tuning in for the first time, we did do this.
Yeah, we did do this part of the CTF, so we'll kind of like chill through it. It is set up correctly this time. Sorry, before we kind of like, I don't know. The idea of this show, at least when I'm on, is usually to kind of show everyone what it looks like to go through things from scratch without any prior preparation except for just knowing about it. And so the goal last time was kind of like, we'll just kind of set it up, 4 minutes before the show starts and it'll work. But there was a little bit more setup involved than I had realized, and so I messed it up. And then we kind of dealt with the repercussions of that throughout.
We were able to solve a couple puzzles.
We did still solve some, which was kind of cool. But this should be a little bit easier for us. It's a fairly straightforward CTF. I say that and I'll mess up, I'm positive. I also, Bavik Knight points out that I had midterms last time, and that is 100% correct. I was coming after like 4 midterms in a final project, paper, presentation, whatever. No more of those. I got all the midterms back. Not great, but like, I am not as exhausted by those. We're
stress is over and done with at this point.
Yeah, exactly. Now it's just like, there we go. And that's what we have. So, also wanted to point out that if you ever feel like I'm laughing too much, you're missing the joke. You're not missing the joke. I laugh too much. I saw a comment on a YouTube video from like 4 weeks ago or something that was like, I don't understand. What's he laughing at? I just like laughing. Don't
Everything.
worry. Yeah, that's the whole thing. I just have fun. I just like what I do. So don't worry about it. All right. So for us, and for our purposes...
And I need to do this too, right?
Yeah, this one will also apply to you. So we will go here. And I don't know if the password is still here. Oh, bummer. I don't have the password anymore, but that's okay. So I'm
if you want, if you want to do something, if you ever need to bring your screen up, let me know, and I can transition us back to our beautiful, not that title card, but the new CS50 Live title card, which I put together today.
No worries.
Which looks fantastic.
Let's see, Stripe, CTF, and sorry, I'll put you back there in a sec. I just need the password for the first level so that we're not all... And you'll notice I'm not even checking the passwords of the other levels. I only have one of the passwords available to me because we are honorable people over here at CS50. All right, so this is where we're going, is level 01 at 54.193.109.232. And so, just as an FYI, you guys should not be able to access this as Colton kind of types that in. This should block you, I hope. If it does not block you, maybe let us know.
They're not going to let us know.
Yeah, I know. Everyone's going to just be in there. So we're going to hope that you guys don't get in. And then I'll paste the password for you. My preferred handle is powerhouse of the cell, which is also my GitHub as an FYI. And that is the password that we have to paste. Sorry.
Whoa, okay. So which part of that am I?
QW60,
Got it,
that
okay.
part. Sorry, there are a lot of things on the screen at the moment. I'll make this a little bit bigger for everyone. Cool. And you'll notice that as opposed to last time, we actually get instructions and introductions and things, which is kind of nice.
I can't read the last letter of that.
Oh, sorry. I am nope, wrong way. There we go.
I think that's correct.
Yep, there you go. You're in. You're in.
Does it matter any of the other information after this point? The handle, preferred handle, etc.?
Nope, all that you can do up to you. I did Powerhouse of the Cell,
Okay.
Which is my GitHub. Yes, as Kane points out, you're not allowed to connect to those. Yeah, I'm really glad you're not able to connect to that. You're not supposed to be able to connect to that. That is just for us to use. You're welcome to set your own up if you follow the bit.ly that Colton posted up in the top, or kind of set it up yourself. But I am very glad you are not able
Folks
to connect.
will have to set it up on their own.
Yeah. And the reason for that is we basically just want to make sure, oh, I can't proc that. So basically we just want to make sure that you guys weren't, messing around while we're in here. And so you'll notice that if I do W, I can see, this is kind of just some sysadmin stuff. I can see that there are 3 users. 2 of them are in level 01. That's me and Colton. And the third one is myself from this screen, which is the CTF user himself or herself. Well,
so
himself in this case.
So level 01. So what's the difference between the CTF and then your version of level 01 then?
Right. So level 01 is kind of just, if you imagine a CTF has several different levels of difficulty, then level 01 is actually a user in this case, but it also represents the first level of difficulty.
Okay.
So it's the easiest level, but it is also, in our case, a actual user that we can log into a machine as. And that's why these kinds of CTFs are somewhat interesting. Is they do give you some exposure to an actual system, usually a Linux system. They're fairly easy to set up on Linux distributions. So this one is an Ubuntu system, and we have several users. We actually have level, we can point out which ones we have, or actually I guess I'll tail. Etsy password, and that tells us that we have these 7 users. Where we have users level 1, 2, 3, 4, 5, and 6, and then we have the final user, which is the flag. So if you are able to log in as the flag, you win.
Are those user groups?
Those are each individual users. They have their own associated groups, but they're all also individual users as well.
Interesting. Okay.
And then the CTF user is an administrative user, so that is what I'm currently logged in as.
CTF administrator. Okay, got it.
Yeah, so I'm logged in twice. This screen has me logged in as the administrator.
And the
this
other
one has
screen
me logged in as Powerhouse of the Cell or level 01.
And someone asked, is that a reference to mitochondria?
Yeah, so actually, there's a cute little story behind that. When I took CS50 as a freshman, that was my first CS class. I hadn't programmed before, and I was like, oh, this is really fun. I'll just kind of mess around, and I was interested in studying bioengineering. I still study bioengineering, but I've added CS. And my TF at the time was like, oh, you guys have to make GitHubs. And I was like, okay, sure, I'll make a GitHub account. I was a bio person, so I was kind of like, oh, Powerhouse of the Cell, Mitochondria, it's funny, LOL. And so I made my GitHub user as Powerhouse of the Cell, and everyone else made their GitHub usernames like, first name, last name, some string of numbers. And so my TF was like, well, who's this person in my section, Powerhouse of the Cell? I think we've since coordinated that in CS50, so they don't have to worry about it. But my TF at the time was very confused as to who this person was, and he asked in class, he was like, hey, who is this? And I was like, oh, that's me. And then I was wondering why no one else had been called for their weird handles, and the reason was they all had normal ones. So yeah, I ended up keeping it, and I really like it, and most of my online stuff is related in some way or another to Powerhouse of the Cell or some other spelling thereof.
All only within the last couple of years, too.
Yeah, all within 2.5 years.
Yeah.
Jeez, that's crazy. Yeah, so we are currently in this directory. You actually should have a different directory if you notice.
Yeah, mine's got like a P9,
yeah.
Y.
Oh, sorry. You get some kind of like random strings. This is just scratch space, so we're allowed to do things in this directory.
So now we actually have a writable file system.
It's a writable file system. Not the whole thing, but this part is actually writable. So I'm going to actually alias some stuff. I'm going to alias the command scratch to take us to this kind of scratch space. And we'll have that just CD into PWD.
So we can copy files here, and then those files we can then manipulate, but we can't manipulate the original files.
Yeah, exactly. So now if I type scratch, I'll end up back where I belong. And this lets me like write things to the file system because the way that this CTF is kind of intended.
Yeah, I should move the chat since it's a little
sorry.
bit hard to see what's going on here. Let me do that real quick.
I can also move my terminal.
Apologies, everybody. Can actually, it might work better if it's like here,
yeah,
maybe.
Yeah. And that way, at least as commands like filter upward, you'll be able to see stuff.
Yeah.
I'll try not to refresh my screen too much.
We'll see if that works. Hopefully that works
Yeah,
for people.
that should be okay. Yeah, so this way I can kind of like keep my Scratch directory as I go. As we log into further users, I'll probably forget to do this at least once, and then we'll have to do that again. But basically, this is just kind of some setup. As far as like how this is set up, the overarching system is an Ubuntu system. It has a series of users. Each of those users represents a level. And then the last user is called the flag, and that's the user you're trying to log in as. If you can successfully log in as the flag, then you win. That's the game. Now, it's intended to be such that each level is more and more difficult as you go on. And I think that given the CTF, that's probably true. From there, what we're trying to do is the overarching system actually has mounted a kind of file system that we are currently in as level 01 through 6 that is read-only, except for a small portion which is writable as well. And that small portion is where you can like write files, copy files over, rewrite text if you want, and so on. And that lets you kind of control how things are working, which is very convenient, I think. So this just kind of set up as like a give you some space to move around, explore the system, work. You'll notice that if you go up a directory and type ls, you actually are not able to see what other users' temporary spaces exist. And that makes perfect sense. We're all in the same like writable subportion of the file system, so it makes sense that we can't see each other's subspaces and then copy them. That would be kind of silly.
So temp is just like that Scratch like domain.
Yeah, and so temp is the Scratch. Yeah, Scratch domain I think is a great way of putting it. And then underneath that, there are kind of each of our subdivisions.
Allocated folders.
Exactly. And if you type cd, you do end up actually in a home directory, and it is the level 01 home directory. And if I type ll, which is now correctly aliased, for those of you that weren't here last time, I kept typing ll because it's a habit of mine, and it was doing nothing. It was like the command not found, and so I had to re-alias it every time. This time it's aliased by default, which is great. We see that we have our .password file. So if we cat that, we get the password that we logged in with. That's the current user's password. Now, if we go up a directory and then into level 02, for example, we can type ll again. We can't cat their password file, unfortunately, but we see that they also have a password file. And so the way the CTF is structured is in everybody's home directory, they have a .password file, and it is their password and also kind of their flag. So if we can capture it, then we can log in as them and we can move on to the next level. And so the eventual goal, is to get this one. That password. If we can get this particular file, then we win. That is the eventual goal. I highly doubt we'll get there within an hour and 15 minutes or so, but never say never and all that. And so the goal of this will basically be to see how far we can get and kind of explore. We are currently on level 1. We've got to get to level 2. The other thing that we have in this CTF, I'm so into that habit of just like cd.ls and so on. LL would be a better habit. You'll notice that we also have this folder or directory called levels. And if we go into this, we find a bunch of executables. So level 01 will run, and it prints to us the current time. If you were here last time, you'll remember that this is a particularly vulnerable application. And then level 02, we can't run at the moment, but we will be able to eventually. And as far as like sysadmining and kind of like UNIX goes, the paradigm is everything's a file, and you get to see all sorts of kind of things as you go. And so you'll notice that this like D here at the beginning, if I do LL, which lists out the long form of everybody's files, that stands for directory. And then everything else is sets of permissions. I don't really remember what S stands for. It's probably, I guarantee it's meaningful. But you have these kind of like R blank X patterns. And there are 3 sets of those. So one of them is for the root user, one of them is for everybody, one of them is for the group that owns this, and then one of them is for the user that owns it. And thank you. Yeah, as someone pointed out in the chat, it's the set UID. So it sets the user ID of the process when it's invoked. That is a great way of reminding me of what that does. Great point. So everything else is pretty much just like, can I read it? Can I write to it? Can I execute it? And so on. And if those flags are set, then you can do those. If you can't, then you can't. and they're fairly self-explanatory. They're also often encoded as the binary representations. So you'll often see people do like chmod 755, blah. And what that means is basically you're using the binary representation of 7, which is 111, and then 5 and 5, which is what 101 and 101. And so what those will do is it'll say, okay, set this one all to true, set this group to true and false and true, and then set the last one to also true, false, and true. And that basically just means anyone can read and execute it. Not everyone can write to it necessarily. So yeah, it's really useful things to know. But basically, when we look into this directory, we have this level 01 executable. And you'll notice that the user who owns it is level 01. The group that owns it is level 02. And I can run it, but I can't necessarily write to it. I'm not given any individual permissions. So if I'm not in the group, then I can't necessarily do anything useful. I can only execute it. And then Tuxman kind of humorously points out, chmod 777 can't go wrong, right? And certainly you can go wrong. That is very wrong. I have seen people do stuff like this. So chmod recursive, I believe it's capital. Might be wrong. Oops. That would be bad. This is a pretty unfortunate command. Has been run occasionally by, you might see like a troll post on Stack Overflow or something tells you to do this. Or you might see an equivalently troll post that's like rf star. This is an equivalent one. This one also works. That's also bad. Don't run it. I mean, run it on like a virtual machine if you want. I think a lot of machines
more catastrophically bad than the
yeah,
other
this one's
one.
like more directly catastrophic. You'll find your file system's pretty well. It's a saver of space.
Yeah,
You're
sure.
very space efficient after
Sure.
that. Your file system will take up a whole lot of space actually. Cool. So we have this level 01. And the Stripe CTF is really not like a systems CTF, so we don't really have to verify that like the code that they hand us, the C code, is the code that got compiled to it. We can more or less assume that it is. Just as a note in general, you really shouldn't assume that. If I give you source code and a binary, but I don't tell you how I compiled it and you didn't compile it yourself, you have no real guarantee that like they even used the same compiler that you might use. And that might be as trivial as like, they use a random compiler, like a different version of GCC or whatever. It might be as non-trivial as they write their own compiler or they edited a compiler so that it prepends or appends malware to anything it compiles. That would be really bad. Also, they could have just compiled completely different code to that executable and then left you a random binary or a random source code, and you'd have no idea. So generally, if you're not compiling code in like a security sense, you really don't know if it is what it says it is. But in this case, we're going to just kind of go off that assumption. And right after I tell you that you can't do that, we're going to do it. And that's because that's not the point of the CTF. So the CTF actually focuses on like logic puzzles and kind of do you know how a file system works rather than that. But that'd be kind of funny. Bob McKnight points out that you can just alias rm-rf star to cd or ls. And Tuxman responds that that's evil. I agree. That's pretty demonic. But very funny.
That's pretty good practical joke, though.
Yeah, no, that's very, very entertaining. And it's a very funny kind of like, haha, unless it's their work computer and then they're screwed. So yeah, maybe like do that to their virtual machines or something. I might throw that in for my club for cybersecurity. Have that be like a level 7 or something. All right, so yeah, with that, let's do some analysis of this source code. And so just as an FYI, we do know the answer. I do actually know the answer to this one. We also know the answer roughly to the second one. So we're really going to like start working on approaches and things on the third and fourth puzzles. But we'll go through this one for the people who are currently here, and we'll take suggestions from the audience kind of like every time. But we'll also kind of point out things that are going on here. Something I didn't know last time, but I do know now, is how system works. So system checks the current executor's environment and looks for this string as a key in that environment dictionary, and then executes whatever's on the other end of that. So you'll notice that if we do like env, and we I'm losing my mind. And if we grep for date, we won't really find anything. Sorry. I don't know why I removed the quotes. Doesn't really matter. But whatever. So if we grep for date after piping out our user environment, we don't seem to get anything super interesting. And you'll notice that I guess might mean nothing to everyone. But just for funsies, I'm going to also alias date. I'm going to export date is equivalent to, let's do like a, what's a common one? Oh, I'm going to have to escape those. Actually, we don't have to escape anything. Echo works like this. We'll do that. And now if I run this executable again, nothing interesting happens. So what might be kind of interesting to do for our users is say, OK, then maybe we should go and investigate how the system function works, right? So I said, OK, maybe it's the environment, and that's what I claim to have remembered. So generally, when I approach a CTF like this, it's pretty much always useful to anything you don't fully understand. You should go Google. And people are always like, oh, no, you shouldn't Google things. Like, you're so slow. But it's like, yeah, that's true in like a specialized field, right? So if I'm sitting there and I'm a systems engineer and I need to go Google every time I want to understand how a kernel, like a protected control transfer works, yeah, that's unfortunate. You're probably going to get fired. But if you're Googling around for things that aren't necessarily in your domain-specific field, then it makes perfect sense. And actually, this one is in my kind of like domain-specific field in that I'm a generalist because I'm a student. But we're going to Google it anyway just to kind of double verify things. Oh, right, I forgot I had that one open. You guys get to see my problem sets. There's not really anything interesting there. So, all right, in C, system, function. Yeah, there we go. Gotta love Google's searching algorithms. So it tells us, OK, we get the syntax for the system function in the C language is that it returns some integer, probably like a succeeded or didn't, and it takes in some string literal, and it says a command line that will be executed by the operating system's command processor. OK, so that's pretty reasonable, reasonably straightforward, but maybe we return and we say, OK, system function returns a non-zero value, blah, blah, blah. And so we want to say, OK, how can we edit this to, I guess, get it to work to our advantage, right? And as we saw last time, there is a way to get this to work fairly straightforward. But you'll notice that this actually just looks for things in the path, not things in environment. So that should be kind of your first clue that maybe what we were attempting as like our intuition for how this might work was not quite right. And when we look at this, it says it's a command line that'll be executed. OK, reasonable. So what I can do, and what I did as a solution last time, though there are simpler one-liners that would also work, is I'm going to say, OK, I want it to look for certain commands that it can run. So I'm going to go into my Scratch space, if I could spell Scratch correctly. And in here, I can create whatever I want. So I'm actually going to move the current folder or file that's there to date. chmod also takes arguments like this instead of just the standard like numbers representing binary. And I'm going to allow date to be executed. So I can execute date. It doesn't do anything interesting, but I can execute it regardless. And if I nano date, because I love nano, sorry for all the Vim users who are like, oh my god, you're so slow and
I like Nano. Nano's nice and it's very simple.
Thank you. Very straightforward. I'm a very simple man, you know?
It's no debate. I don't think that Vim will perform better when you learn how to use it.
Oh, for sure. If I knew how to use Vim, I would, one, be very much more intelligent, and two,
of course,
I would also be much faster. But you will all be horrified to know that I also can't touch type. So if you see me looking down at my keyboard, it's because I'm finding the keys. I have a terrible, terrible touch typer. I have been working on it, but I would touch type at the speed of like a kindergartner or something.
Okay, you've only been doing CS for 2 years. Though,
that's true. So
good,
I mean, we'll count that as an excuse. It's a pretty miserable excuse, but we'll count it.
Robotti and Crazy Cat Kiki Craft, as well as Boots CK and Trickster Z. Thank you very much for the follows. I love all the name variety.
Yeah, the names are just always fascinating. Also, now if I execute date, you'll notice that it prints out hello to my console. Oh, I just realized. No, yeah, you guys were able to see that, I think, the whole time. So basically, I edited date. I gave it my kind of favorite shebang bin bash. And then I gave it an executable kind of command. And now, if I go back into this levels, typing in the real world horrifies me because I will never do it correctly.
There is a curse with typing live.
Exactly. Oh, anytime. Anytime I'm live, it's even worse.
Or with somebody else in front of you. Yeah.
Every time. Every single time. And you'll notice that when I go and run level 01 again, it doesn't really do anything interesting. But what I can do is I can say, OK, you know what? Let's update my path. Let's prepend. Oh, I probably should go back into Scratch just to make this a little bit easier. So what I can do is I can export path, which is a variable that represents where things look, or where like programs look when they're trying to like do stuff. And I can run this command, which updates path to include the current directory as well. And you'll notice that if I echo it, it also includes this directory, which is my current one. And what that means is that if I go to run a command, say date, for example, it'll check that first. So it checks everything in your path in order from left to right. And what that means is that now date, instead of being the system date, is, oh my god, I can't type for the life of me, is actually the date that it found first, which is in my scratch space. Right. So now, if I go into levels again, I guess I could have equivalently done cd dash for those of you that are not like, or are like me and don't like typing as much. If I run level 01, this time it returns to me hello. And that's pretty useful. I can now arbitrarily change the output, and I know that it's owned by the group level 02, which means it has access to anything else that is owned by level 02.
Like a file that we were kind of interested in earlier.
So I'm going to nano what date is. And instead of having it echo hello, I'm going to actually have it cat out for me. Let's see if I remember this. Dot password.
It was home. Was it levels?
I think. Well, so this one is actually their users directory. I think that's about right. We'll double check that though.
Okay. Right. Okay.
Yeah.
I think I remember. Yeah.
Oh, let's go here, and we can actually ls home level 02. Just double check. Okay, cool. So that directory exists. We're good. Oh, and I forgot the spacebar. Killer. Never mind. Not worth it. We know this works. I could show that to you, I guess, but oh, and I can't run that. That's unfortunate. Oh, sorry. Right, because I can't have this actually be running from there. Oops. So what we'll actually do is we will have. Let's just rewrite. I can't cat it because I can't have it do that. Let me think of what I actually want it to do. So I want it to execute this command. Well, we could alias date. That might work. We'll find out. Next on this version of We Mess Around with Systems.
When in doubt, always use sudo.
Yep. Yeah, I wish we could use sudo. Well, let's try sudo. That's a good point. Nope, can't do sudo. We got to think about this slightly more carefully now that we're in a proper file system. Oh, I see. I was like, huh, and interesting. I mean, I can try it. I realized you were reading off the chat. Very nice.
Was, yeah.
Very
As
nice.
you know, I don't know anything about hacking or anything. So
no, it's all good.
Anything I say.
So we get this permission denied error, and that basically means that cat is being run by by me, which is not useful. So what we want is for .level01 to execute. I'm sorry, not what I wanted to type. We want level 01 to execute this system call where date is actually just level 02's password returned to us. And so the way that we can go ahead and try out different ways to do that would be something like, excuse me, the things that we have done so far, which is creating a version of this that, excuse me, is, what was I going to say? Oh, sorry. If we go into Scratch, I'll show you what I'm talking about so that I can contextualize. So we have this version of date, which is executable, and it's owned by level 01 and level 01. We might actually be able to do this. Level 02, date. Huh, sad. I can't change the ownership of that. Unfortunate. So what I will do then is...
How did we get it working last time?
Well, last time we had some extra help because we also had access to the owner of the system. So I think my permissions were set by accident correctly.
Oh, I see.
Yeah, so this requires slightly more finesse than what we currently are attempting, but that's okay. So let me actually do this. Oops. So what we're going to do is move date to dated. And now if I type date, I'll still get this error, but that's because of my alias, which says, okay, date is this. And then if I run level 01, this goes back to doing what it was doing normally. And so what you can do is actually this. If you do which date, that actually tells you it's bin/date. And that's all reasonable. So what we want to be able to do is we want to get the output of kind of catting level 02's password file. But we're not given permission for that because it's being, however this is being executed, when we run level 01, it's not transferring the kind of permission set from level 01 to the command underneath. Although it really should, under my understanding. So what we're going to do is play around with kind of just different ways of getting it to do that. We could do it in kind of a one-liner sense, where let's see, if we... What we could probably do is this. Let me go back into my Scratch space. Oh, so my Scratch space is also owned by the wrong person. It's owned by me and only my group. So what we can actually try and do is get date to be executed by this, and I want date to be on my current path. So I think I can set env. Oh, no. That is a function from maybe not this language or this system, but that's okay. So what we'll go ahead and do is see if I can get a catted version of that file printed out to us. And I'm going to think through how to do that at the moment. So there are there should be a way that I can't think of at the moment that doesn't deal with export but is close. Let me think about what I'm trying to do. Any suggestions, Colton? I'm trying to recall.
So your goal is to print out what's in the
export.
.password file in level 02, right?
You got it.
Which would be just cat.
Cat would
level
work.
02.
There are other versions of that command that would work. But I'm also trying to get it to use kind of the right executioner.
So why isn't it executing date since the executable has the level 02 permissions?
Yeah.
Why is it not executing the file as level 02?
Well, that is a great question. My understanding is that it's because of where date is actually written, which is not ideal. So what I need it to do is use kind of my own custom command, and I don't remember how I would set that just as like a general command line statement. And I believe it deals with I could set kind of this date command in my current directory. Oh, actually, something that I could do is alias date itself. Oh, well, I can't edit. If I go into bin, I'm fairly certain everything here is owned by root. Yeah. I was going to say I could actually just create a kind of like a version of date that is aliased and.
Did they mess with date? Just out of curiosity.
Might as well look. Not that I see.
Looks the same.
Nope, that looks about right. Yeah, so my guess is that it's the way that I've written it isn't quite right. But I also am aware that I should be able to set it, and I'm blanking on that command. So here's what we'll do. We'll Google it. How to set a command on path. This is something I should know. No, Linux.
On Windows XP?
Yeah, Windows XP, so useful. Yeah, they tell you how to set the path variable correctly, which is fine.
The set command?
Yeah, let's take a look at set. Gotta love man pages. Oh, there's no man pages. Unfortunate. So what does set do on its own? And we'll kind of just keep looking around. I am somewhat confused as to why that doesn't quite work. It is very annoying. You'll notice that there's like handle is set here, and what we're looking for is actually just where I can set my. Oh, never looked at that. Where I can set a command to be run called date.
Date's right there.
So date is set here, but date is obviously not what's actually being run, and so I can't actually do that one, unfortunately. Because that one, I believe, would actually execute with the right permissions. I am somewhat surprised that this one was not. Oh, well, actually, no, I'm not. I really should have done this. So what we're doing is called an experiment. We are trying out some things. So what we're going to do is we're going to try out a bunch of different things, and there we go.
It's because it was using the.
I was having it use my own bash. Yeah, sorry.
That would make sense.
Whoops.
Okay, that makes total sense.
Yeah, so there you go. Yeah, don't overcomplicate things. Good thing to remember. So now what I can do is.
Do you want to explain for people who might have missed that?
Sorry. So was like, you know, it's very easy to overcomplicate stuff. So if I go back to that directory and I nano date.
And also, why don't you explain what we just did too?
Right. So we'll go through kind of the whole thing here. So I had this flag at the top, which was execute using /bin bash. And when I went to level 01, so level 01 is now currently executing whatever command I put in date, and it is supposedly executing it with the right permissions. Executing it as part of level 02's group, and level 01 is the user. The problem was that it was saying permission denied, and I was kind of confused by that as well. I actually didn't notice that I had done something that would mess that up. But if you look in that folder, or in that directory, sorry, no, same word. If you look in that file, the executable, if I remove the shebang bin bash, which tells it explicitly which shell to use and things that might not have the right permissions, it kind of dictates some of the permissions, then you'll notice that this actually works just fine. And in fact, gives us the password for level 02. And the reason for that is just that I was kind of accidentally messing with the permissions with which things were being run, whereas I should have left those alone as much as possible. Good to know. So from here, what we can do is, we should also explain what this is. So basically, if you look in level 01 as the code that supposedly is being run, and I believe is being run, there is this kind of printf the current time, flush standard out, so just wipe out whatever things are in your buffer, and then call the system date. So this is whatever the command line argument, whatever the command line function date is, according to the user who calls this file or this executable. And what I've done is I've exported my path variable, which is where your computer, where a Linux computer will look for things that can be executed. And I've changed it such that it uses this directory first, which means that if there's something in that directory that is executable and it's called date, it's going to execute that instead of whatever it finds later. And because of that, we now have access to whatever level 2 has access to. So that means that I can do su level 02, su being switch, su doesn't exist. All right, then we'll SSH. Level 02 at 127.0.0.1. And yep, that's fine. And we're going to paste that password. And here we are now in the new new user. So we have gone up a level. We get a new temporary directory and all of that jazz. So what I basically did there was I just SSH'd into the machine itself from where I was. And what this basically does for me is it says, OK, you've now moved up a level, and you are on the next level, which is level 02. And from here, what I'm able to do is attempt level 02. So you'll notice I get a new Scratch directory. Again, I can't actually see other people's Scratch directories, and I get my own home directory. This time, .password has level 2's password. So from here, if you noticed at the top here, they give us some instructions. Oh, that's cute. Thank you, Stripe. So they give us some congrats, pat yourself on the back. You made it up from the first level. Excuse me. And you get the password for the next level is in level 03's directory. Now, this one is web-based, so we want to go ahead and go to a browser at level02.php on the server. We have to use kind of the standard password authentication, and then we can see what's going on in var www dot, and so on. And so what we're going to do first is let's go look at that source code. And there's level2.php. And so if I print this out, it's a PHP file. Looks good to me. And then we're going to go to this server at level02.php. So let me, I don't remember the IP of this server. Oh, there we go. So we'll go here. Yep. Oh, that's cool.
I think you have to go to /level02.php or whatever. Right?
Oh, sorry, yeah, /level02.php. I was like, oh, that's nifty. Oh, right, and then we need level 02's password, which we have. And we'll copy that. Our username is level02, very secure. And we go over here.
Nice.
Cool.
So this is effectively where we left off on last time.
This is where we left off last time, and we will...
And I mean, we also did, I think, have to do more this time to get past level 1, too.
Yeah, this time we had to actually do the proper CTF. So here we go. Now, this time, as we kind of noted last time, if you go into application and cookies, we see that there is a cookie that is set here. It's some arbitrarily like created string.
Yeah, it's just a randomized
Just
string, right?
cute.
Or
Yeah.
UID or whatever.
There's just kind of this like string. It's a .txt file. Seems cool. We don't really care. It tells us a little bit about our browsers from like the headers where we're accessing things from. It tells me I'm 234 years old, which is great. And it tells me I'm NW, stands for not worldly. That's my name. Yeah, that's really insulting to myself. Go figure. And let's see, if we go into TMP and kind of look around, there's nothing in here. All right, cool. So we haven't found anything interesting, and it seems to me like all of this is reasonable. Now, we immediately went and looked at cookies, because that's where we were kind of at last time. Also, generally a good idea to see what cookies are kind of set in CTF.
We ended up grepping through the PHP file to find out last time if they were planning cookies,
so
right?
we did find, if we less level 02, oh, what the, can't spell. Big problem. Learn to spell it, kids. So yeah, if we look through this PHP function, there's this kind of generate a random string function. Seems reasonable. There's an output with nothing in it. And then this. And this is where we kind of knew to look at our cookies. It says, hey, if not is set cookie, then set the output to, hey, there's some random user or first user. And then, or first time user, sorry, and then get a file name, which is just a random string. Hey, it's a function we saw above. Probably creates a random string. Shocking. Yeah, crazy. And then this is the concatenation for string operator in PHP, and it appends the .txt extension to the end of it. And then it opens that file in temp/level02, which is good to know. And it says, okay, from there, we want to create this file for writability, and we're going to just save some data about that user. And then from there, we're going to blah, 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 continue on, set the cookie, and move on. Seems reasonable to me.
So,
cookies are stored in your browser. Pretty reasonable.
So we could maybe copy a file to that location and have it...
We can. So
can we
let's
edit this
see.
PHP file, actually? Is there a way for us to?
No, I don't think so. Well, we can just check ownership. Nope. It's owned by level 03 entirely.
Okay.
And if we go into /tmp, which is where, yeah, we don't actually have access there. So even if we were to go into level 02, also denied. So we're not quite able to access those files directly, but I think that's the right intuition in that if we can't, oh, sorry, we'll less it just so that everyone can read. You'll notice that if the file is set already, so if that thing is already set, then the output is actually just set to file.getContents of whatever is in this directory catted to the cookie. So what might be really interesting to us, is
trick
to
it
trick
into thinking that it wants to load the password file.
Exactly. And you'll note that we can't use an absolute path because it prepends this /tmp/level02, and that kind of immediately indicates that maybe it's vulnerable to this kind of like relative pathing exception set. So relative pathing, absolute pathing can be very confusing. And so if I start something with a slash and then continue typing stuff, so like /home level 02, for example, that's an absolute path. I know that oh, sorry, I didn't give it an actual command to do with that. But that is an absolute path, and that means, hey, / is the root of the entire file system. And so from there, you can access anything inside of it or whatever, but it's going to start at the very root. So if we go into root, we see all of the things that are available to this current file system. If we wanted a relative path, then we might do something like this. I'm in my current home directory, so I can see where that is, and it gives you the absolute path if you do pwd. But I can go relatively to level 03, for example. And .. means go up a directory, and then whatever that directory is, / means inside of that, and we can go from there. So what might be really useful to us is if we remember what, var www, what this was, then if we look at how this file_get_contents is, we could go up 2 directories, and now we're at the root, and then /home/level03/.password, and it would get the contents of those and set them as our output.
/home/level03/password.
Yeah. So
.password.
we're gonna go ahead and try that out.
Let's try it out.
So in our browser, I'm going to try and set this cookie. So let's go ahead and edit this value.
So this kind of assumes that you have a browser that's capable of doing this. I think you can still do this.
You can do it in curl. You can do it on command line.
Yeah, you can do it with like curl or whatever,
Yep.
right? Or wget.
We could also certainly curl this. So what we're going to do is .. /home level 03.password, and we're going to go ahead and refresh the page from there. and see what happens. So we've set the cookie. Everything seems pretty reasonable. We're obviously not a first-time user. Stuff is going on. And we've refreshed the page. Our cookie is set, has not changed. But we don't see anything immediately change. So let's go ahead and take a look at where things are here. We don't see anything useful, actually. So nothing seems to get put out. So my guess is that maybe we're doing something wrong in how we're setting the cookie or something like that. So as I mentioned, you can do this with curl, actually. So let's do some kind of command line version of this, and that'll give us a little bit more direct access to everything that gets returned to us. Okay. So we're going to go ahead, and we're going to use curl. Now, curl has all sorts of cool functionalities, so we're going to kind of man through it, and I believe it's like --set -cookie, and we can specify which cookie we want to set and then query things. Oh, that's a lot of things. Oh, there we go. Actually, what I should have done is this. We're going to Google set cookie curl, and that'll give us a direct command line syntax for it, which is very useful. Cool. So what we're going to do is curl the website, curl ourselves, actually. So we're going to go into our own home directory, and we're going to curl dash, what was it? You would think I'd be able to remember this after so many times typing things like this. User token, so this is where we need the cookie's name. If we go into application, it's user_details, user_details equals, I think is the syntax. I always hate messing these up. Yep.
Yeah, it looks like that's correct. Yeah.
And then we'll copy this, paste that here. And we can do 127.0.0.1 / level02.php. And oops. Oh, right, we need an authorization required. So let's go ahead and curl authorization header. Actually, we're not really using true authorization. We're using, what's it called? HTTP digest. Oh, maybe it is an authorization header. We'll find out. Username and password seems good to me.
Seems pretty accurate.
I like it. I like simple. So we'll say user, and we'll say level 02. Oh man, I don't remember password. So what we'll do is this. Cat of .password. Seems good to me. Oh, that's a bad.
Is it .passwd?
Might be. I'll just cat it out. No, that's the right one.
Oh, it is, okay.
It might have not bash completed, though.
Like did interpolate.
Or it's just entirely wrong, and we'll find out. We'll find out next on this episode of how many times can we mess up in different ways? We. That's so cruel to Golden. It's not a we. Like, I'm messing up.
Well, no, I would not be getting us any farther.
So we're still not authorized to do it, but I think that's just because we don't need this kind of... yeah, we're not doing OAuth either. I think our authorization is... Oh, I see. So if you use like the user thing, then that creates this header. That's good to know. But we're not necessarily doing this. Oh, this might be right. I mean, I guess we should have used their kind of standard.
To answer Kane's question.
Oh, yeah.
Had to take a call, missed the fix for level 1. What was wrong with the initial script they injected? And that was the bash.
Yeah, that was us kind of setting our own version of it.
Yeah, we had a shebang that said, what was it? Was it user bin bash?
Yep.
Instead,
we were using our own kind of like bin bash, and then we were using kind of a. It was setting its own permissions as the caller or the owner of the script rather than the caller of the script.
Right.
Oh, --digest, not user.
Why not just edit the cookie named user to level 03, asks Fitislav. I don't see anything that is done that prevents you from reloading the PHP file with a different username, and you will get the next password.
I'm not entirely understanding what you mean, but I will take a guess as to what you would like. So they say, why not edit the cookie named user to level 3? We don't actually have a cookie named user. We only have one cookie. It's called user details. And I can't necessarily just edit to be level 03 itself. I need it to be the password file that they actually have. I'm also not able to edit the PHP file. So you're very much correct in that if I could edit the PHP file, that'd be great. But it's owned by Level 03 themselves, so I can't touch it. Meaning I have to kind of use what they've given me to mess around with things. And that's often how these kind of like vulnerability exploits and CTFs are designed, is given some set of tools that you have, how do you use them to mess with what you're doing? And I think that more clearly explains what's going on.
He's saying on the browser locally, edit the cookie.
Right, so that is what we did, but we suspect that there might be something weird going on with how we're doing that, and that's not quite right for us here. I can't seem to authenticate to the browser correctly. We can go back to it and make sure that we're setting things correctly. But if we reload this page with that cookie set correctly, seems fine to me, but if we explore the actual return, there is nothing useful returned to us. We could also go here. Oh, there we go. Yeah, actually, great idea.
Did you need to hard refresh the browser?
Yeah, I forgot to refresh the browser correctly.
Oh, okay.
So that is our password now. I was like, huh, that's weird. Yeah, so curl would also work, and if I could figure it out, I would, but no need. We now have it. So we're going to, we should explain what's going on first, and then we'll keep going. So for anyone who just hopped in or wasn't necessarily looking, user details is a cookie that was set. We know by looking at the PHP file itself that it just goes and grabs whatever the contents are of the file that has been provided. And it thinks that it's safe because it gives us /tmp/ some actual file directory and then expects a file name in there. But we use relative pathing, .. to take us back up to the home directory, the root directory. And then we go down from there from home to level 03 to their password file. And then it actually just prints it out for us, which is very convenient. And as was pointed out, it's very convenient to set it in the browser. I just forgot to refresh the page correctly. So my keyboard command that was doing it was not quite right. Equivalently, you could do this with curl, and it would do the same thing, except it would print it out. I'm not super familiar with curl, thus the Googling, but if you were familiar with it, then it would be very convenient for you to just authenticate yourself and move on.
You can only have so many things at the top of your head at once.
Yeah, exactly. Could not create a directory. Well, actually, let's hard fail that one. Maybe I can sue. Dang it. I don't know another way to switch users in Linux. I always use sue. So whatever, we're gonna SSH. And it's not a writable directory, so it kind of makes sense. We'll just go up to. And yep, that's fine. Here's the password. Hey, and we're on level 03. So my preferred handle is still powerhouse of the cell. That's not going to change. We have a new directory here, and so I'm going to alias scratch again, because that comes in handy from time to time. And this will be to pwd. Cool. So now if I type in alias, I'll see that scratch aliases me to here. If we look through the instructions that we got, the password of the next level is in the place that we expect. And as before, we may find the levels scripts useful. The supplied binary does mundane tasks. They're always very funny how they do these. We trust you'll find a way of making it do something much more interesting. Igor Voltaic says you can try login. Didn't know that was a command. Cannot possibly work without effective root. Good suggestion. Didn't know it was a thing. More you know. But no, I'm not allowed to do that either. Good to know that.
Kanatelka Mike says hi from the Ukraine. Hello, Kanatelka Mike.
Hello.
And that BB Panther 333 also thank you for the follow.
Yeah, appreciate it. All right, so let's go ahead and run level 03. And we get level 03, index string, possible indices, something to upper, to lower, capitalize, and length.
Interesting.
Okay.
Do we have access to the source?
We do. I was going to just...
Oh, you're just going to mess with it?
I was going to mess with it. It seems to just do those things.
Okay.
It's kind of nifty. Okay. And I'm going to take a wild guess and say that returns 5. Shocker. And yeah, so, okay. Seems pretty reasonable to me.
So we're probably going to have to exploit maybe like a bounds checking error or something?
Sounds like it to me. It might have to do with some buffer overflowing that they might have not
They do
thought
specifically use the BUF to maybe try to hit.
Yep, it does kind of point us at a buffer overflow of some sort. So it looks like if our supplied string is greater than 64 characters, we may have a slight problem. And it says Oh, well, so actually what it does is it copies it -1 into this buffer.
Right.
So it
It's gonna make
copies
it a string,
up to that.
so it adds the.
Yep.
Yeah.
And then it adds a null byte to it, and it returns that. Okay. FNS index. What is FNS? Oh, it's an FN pointer.
Function pointer. Yeah.
Cool. Okay. Oh, that makes sense. Very cool. This function is now deprecated. I'm a huge fan of deprecated functions. Those tend to point some interesting things.
Interesting. Okay. So you
Okay.
pass in the function pointer to run, and then have it execute. Okay.
It's good to know. So if we can get our return address to be this one, or this this call, then we'd be okay. We could get it to return system of whatever we want.
Whatever string.
And actually, maybe we should just kind of make a new version of whatever string we would like, but we'll get there when we get there. We'll have it execute arbitrary code first. And then we're going to kind of skim through the rest of these. We have 2 lower, 2 upper, and capital and length. I'm going to take a guess and say they probably do all the same thing in terms of like they probably take a first step and capture. Oh, so the first step is probably in main, actually. Yeah, so here is our int index, FN pointer functions of the number of functions, and it has the addresses of, shockingly, every one of our functions.
Does it have the toString as well? Or the whatever the deprecated one was?
Yeah, so our deprecated one is run,
Okay,
and then we
is
have
run in there?
truncate and call, which is adorable, and
interesting.
sounds kind of interesting. So
so
this
runs-
calls the actual function on buffer.
So run's actually not in the function pointer array though.
No, it is not. But it is in the actual, we'll say, bytecode of the file. So if we use GDB, we'll actually be able to see where that is.
Oh, okay.
And we're going to take a look a little bit more just to understand exactly what's going on. It does an index A to I, says if the index is greater than or equal to the number of functions, print out some error, give us the indices. So we're not going to accidentally go into random things there. And then it says return truncate and call. There's our beloved truncate and call of the functions that we have, the index, and then whatever the second thing we passed in was. And so Fiteslov, yeah, maybe, says this is a privilege escalation function, use it. Yeah, technically everything we're doing is privilege escalation. The whole CTF is actually privilege escalation. Privilege escalation meaning, hey, I have as some given user some set of privileges, and I want to escalate those privileges or make them greater than the current set I have. And oftentimes that involves either granting your current user some new set of privileges or getting access to another user who has those greater sets of privileges from your current user. Either works. They run equivalently in terms of like you get more power, and that's what you're after. And the eventual goal is often to get root or kind of master privileges if you can own the system. So a lot of the terminology around this is like owning a system or rooting a system or getting root privilege or so on. And that's what we're really after here. So yeah, this is exactly what we're trying to do. I believe the function you're pointing at is run, which allows us to run something as, kind of as we saw before in the level of 1, the run function.
Right.
And so what we're going to try and do...
It's deprecated though.
It is deprecated, so it doesn't... It's non-existent anymore, supposedly. But the problem with putting code like this into a file, as we'll see, is if we run GDB, we can actually tell what the address of this function is, and from there, we can have that return address be the thing that actually gets returned instead of whatever is here.
Right.
And if you know a little bit about how assembly works, and my assembly is somewhat rusty, but it should be a little bit better, we just need to figure out whatever the first argument was, which is I think RDI is the register, and make sure that RDI, and you'll notice RDI is this FN pointer star possibly, but that register might get changed in the assembly. We need that RDI, oh, actually, sorry, it'll be buff. So it'll be whatever's in buff. We just need that to be the right thing for system to call. So we're going to do a little bit of setup, and then we're going to see if we can buffer overflow some stuff and move on from there.
Excited.
So if we go into our scratch space, we're going to do, oh, yeah. So you'll notice I messed up my alias and forgot the CD part. So I'm currently just printing out functions. There we go. So if we go into Scratch, that worked now. We're going to make, again, touch. I think that's kind of cute. Oh, nope, wrong.
They got two.
Didn't think that one through. we're going to just echo hello. So if we can get hello to print, we'll know that we have arbitrary execution, and we can go from there. And we're going to do this, chmod plus x, and gotta keep yourself entertained. People are too serious when they program. That's what I think. So what we're going to do is then we're going to run level 03, I believe we're on, through GDB. No, it's a, so upsetting. That's okay. We're going to go into Scratch, which is not a read-only file system. All right, GDB / levels, whoa, I can't spell for the life of me, 03. All right, so, oh, nope. Cool. So no source file is available. I probably should have specified a source file. If we click run, no such file or directory. What? That's unfortunate. This is where you get to see me misuse GDB and probably cause all of its creators to roll over in their graves. Is that not correct? That looks right. I think you can, well, we'll see. Oh, not a core dump. Okay, good to know. We may do some Googling on like basic GDB syntax because who has time to remember all that? Basic GDB usage. I just really want to, oh, I don't want that. Cool. GDB tutorial. Okay, I don't really need a full tutorial so much.
It's like the exact same font and style as the CTF that we just did. Yeah.
I think there must be like a standard thing. Okay, file. This is not super helpful.
I wonder if that was supposed to be a hint. Like,
might have been a hint. Like, go Google some syntax, you know?
Yeah.
All right, well, see, when I had to use GDB for a class, I was like a master of syntax, and now I'm not so much.
It fades fast.
Yeah, it really does. Level 03. Oh, that was cool. Oh, okay. Yeah, so actually let's give it a /levels/level 03.c. Not an executable. Oh, okay, so that was right. I'm not crazy. Maybe I am. And then, oops. Oh, not what I wanted. Let's type layout. Invalid layout. Sure. But you still did something. There we go.
Okay, cool. So we have the addresses of everything in the program.
Yep. So we're going to go find, I used to know how to do all sorts of cool things in GDB, and now I know nothing. Oh, not what I wanted, whatever. We'll go search for it ourselves. So we want to go find the address of run, and so here's main. Let's see if we can find where run got put. We may run past the end. Oh, nope. We're going to go up the other direction.
It's a lot of C library stuff.
Oh, shoot. Die. We're going to do that again. Froze on me, and I think that was my own fault. All right, let's go up and see where run is. There it is.
Nice.
And you'll see that the return address of run is here. So what we want to do is we want to get this call function, or this call, to execute with the wrong thing inside of it.
So do you want that address on the very far left, run plus 12, to be essentially what gets fed into that function?
Almost. So we actually want the calling address of run, so that the return address goes to run and then executes everything underneath it. So there's this kind of like push, which kind of just tells you where to like set your stack pointer and things like that. But we want to go to the execution of run, and we want our RDI register to be set with the right thing for us to use. Okay. And this is our hexadecimal address that we want to go to. So now we just need to convert that into the equivalent characters and have that be the last thing that actually gets returned. And so what we're looking to do, if we, I don't know where I was going, but I was going to go somewhere. Did I copy that? Yeah, I did. Cool. If we cat levels/level 03.c, you'll notice that it returns this like truncate and call function. And then when we go to truncate and call, when we get to the very end, or kind of like as we go, it will have copied into buff whatever our user string was, the first 63 characters of it. And then the 64th character will be a null byte, and then it returns whatever that is. So it's whatever the functions at index operating on buffer is. And so what we want to do is we want to essentially replace that or kind of overwrite past this what they actually wanted for us. And so we can actually do that not too terribly by providing them just things that are too long. So we can go ahead and do that. Let's go ahead and, oops, not dot slash, /levels /level 03, and we're going to execute this with just something that is way too long. So let's just kind of like throw in more than 64 characters. And generally, I vote for this kind of like experimental, oops, forgot the arguments, experimental approach, just because even if you don't necessarily know what you're doing, you could still kind of figure it out. And I prefer that. And so you'll notice that this got cut off way before it got to the end of our string.
Yeah, I'm assuming that properly cut off the 64 characters.
Yeah, correctly did what we were looking for it to do, which is great. Appreciate it. So what we can do is instead of manually typing all of that, we can actually just do like a yes of some character. And you'll notice that this just prints the character C to the screen over and over again. I can't quit it. You would think that yes would let you quit, but that's just because the print is going on for a lot longer than the actual function is running. There we go. So once we use yes, we could use yes of any individual character, and each one's going to be 1 byte. We can pipe that into like head 0, 1. Oh, whoops, it's a fraction. 1, and we'll get stuff like this. And we can use all sorts of things to do this. What was I going to do? Oh, right. I don't really want lines, though. I'd rather have just individual. I don't really remember how to use yes entirely. You'll find that I don't really remember how to do everything. I was hoping it had like an argument for just individual. Print single.
Isn't it like greater than
character.
sign?
So greater than sign would like push it into some sort of file.
Oh, okay.
Oh, actually, what we can do is just Python it. Python? Yeah. So what we can do is actually just write a script that generates this for this. So what we'll do is touch character gen.py nano, and what we're going to do is just for blank in range 64.
They actually have syntax highlighting in this version of Nano.
Yeah, gotta love Nano.
Wow. Nano that I have on my machine doesn't have syntax highlighting.
Unfortunate.
I know. It's kind of terrible.
We'll give it, I guess, like C for CS50?
Sure.
Question mark. And then end equal, oh, this might be Python 3 syntax.
The end, yeah, you have to do print without the, you have to do print space.
Oh, is it just like, how do you not print the new line?
In Python 2?
In Python 2, yeah.
I don't remember. I think it's, I think you need a comma at the end of what you're printing, but it's been a little while.
Yeah, I don't use Python 2 a whole lot.
It has been a long time.
Yeah, trailing comma.
Nice
job.
Trailing comma, cool.
Nice intuition.
A little bit of my memory that was just kind of roughly there.
Yeah, that was good.
Like a phantom.
And I
That doesn't make it exactly print what you're looking for, though.
Oh,
because you need it to be without the parentheses.
Wow,
Yeah.
that's wild.
Nice.
There we go. And it prints a space. What is that?
Oh, yeah. Can we make it not print a space?
This is really an exercise in us just knowing how to use Python 2.
Use sys.standardout.write.
Oh, okay. That's fine.
You're going to have to import sys,
Yep,
though.
we will need sys. Oh, not what I want. Well, okay. I do need to import sys.
Yeah.
Or I, comma.
It is hard to type in front of people. I do appreciate how difficult that can be.
There we go. So we get 64 C's all in a row, and that's it. Nothing particularly interesting. But what that means is that we can now be at the end of our buffer. And so if it is somewhat annoying not to have multiple screens. Do I have screen on this? Nope. That would have been so useful. If we look at level 03.c, you'll notice that in this truncate and call, we're only allocated 64 spaces, and they try to basically, oh, yeah.
Yeah, you could. I think you
That would
can
work.
do that too. Yeah.
Yeah. Although I'm trying to be like very explicit in what exactly I'm printing as an FYI. But yeah, that would have also worked. It's a good solution. You'll notice that they do kind of make sure that it's like whatever the size of buff is -1. So they're only going to copy in 63 characters. But what we can look at is what functions that are called here might also do something kind of strange, for example. So we're going to kind of mess around as we go. We don't see anything too wild with how this works. They use putchar, which just puts it out into standard out. So we do have to figure out a way to perform a buffer overflow, given what we see here. And we know that 64 characters is roughly the limit, technically 63. Anything after 64, though, and it's not going to get copied over, supposedly. So what we want to do is try and overwrite parts of what's going on. So really what we want to be able to do is overwrite the address of this with the address of something else by writing out some form of gibberish beyond the line that says we could.
It's not enforcing that index falls within a certain number, right?
So index actually deals with the functions part. So yeah, it does. It ends up actually just checking that index is the right number.
Okay, I see.
Yeah. And then if index is negative, it doesn't do anything, which is kind of good to know. But I don't think you can actually give it a negative index. Or maybe you could, and it wouldn't really help us. So we do need to kind of think of a way to, in kind of the binary of this code, we want the next address set here to be the address that we copied over, or the one that we saw before, which is the calling address for
the run function.
Yeah. So we're gonna have to go and figure out how to do that. From here, we see that the char array has just this, and we can't seem to copy over something bigger than size of buff -1. And that one is where I'm gonna have to we'll have to sit and think for a moment, or we can Google it.
Is it 100% a buffer? Could it be a red herring?
Could be. Could very much be. Although I have a feeling this is probably the right
Vector.
right concept. Yeah. So let's take a look. Let's take a look at stir and copy. I mean, I would imagine that it just does what we think it does, but you know, maybe it doesn't. Okay. So this says some size t, copying from source to destination. And it copies the bytes 1 byte at a time. Beware of buffer overruns. That's kind of cool. So maybe we go ahead and take a look at how to perform a buffer overrun with stir and copy. One valid and intended use. Okay, actually, let's keep reading their man page because it's kind of funny. So you read, some programmers consider stir and copy to be inefficient and error prone. The size of destination is greater than the length of source, then stir copy is fine. But one valid and intended use of stir and copy is to copy a C string to a fixed length buffer while ensuring both that the buffer is not overflowed and that unused bytes in the target buffer are zeroed out. Oh, interesting. If there is no terminating null byte in the first n bytes of source, stir and copy produces an unterminated string, and then you can force a termination. Oh, so this actually seems like a valid use of the kind of function. So what we're going to do is we're going to go ahead and see if we can figure out a buffer overflow. And maybe that's not, maybe you're right, maybe it is a herring, a red herring, with stir and copy. Oh, why is stir and copy insecure? I'm a huge fan. Beware of. And I love these kind of like, oh no, this is not good. Doesn't require null termination. Okay, so that assumes that we don't null terminate, but we do actually null terminate.
These answers seem to be aligning with where our minds are going.
Yeah, but they also seem to point out that this part is required, and if you don't do this, then you're in trouble.
Yeah,
but we do actually do it.
They're clearly doing it, yeah.
So that is kind of annoying. Unfortunate for us. So maybe we need another solution. Oh, well, actually, how are they Where are they storing the buffer for argv? Oh, so it's just argv.
Oh, Andre was saying stern copy is not stir copy. Are we looking at two different functions?
Right. But we are, so stern copy and stir copy are kind of part of the same family of functions. We were actually looking at stern copy, not stir copy. So just as a FYI, because this is actually stern copy. So the n refers to just including n number of bytes rather than just the string entirely. So, I don't know. They're communicating amongst themselves. All right, so what we're going to do is look through the other kind of two problems. So yes, the idioms for memcopy, thank you. So the correct idiom with stern copy is the following. Okay, so
Right, which
they
is what
do
they're
say,
doing in the...
Yeah, that is pretty much exactly what they do. So I don't necessarily know if we can overflow that. My intuition, though, is that this is a good, the right path. Maybe we're on kind of the wrong function in particular. So my next guess is, can I overflow? Can I overflow argv? I don't think you can, but maybe you can. Oh, I could actually do a stack overflow. So we just write outside of the stack entirely. So we could actually do a stack smashing kind of attack. That might be.
And how would you do that?
Might be
in
worth
this
it.
case?
So basically, what we're trying to do is you're in any given like call to some process or function, you have a certain amount of stack that is allocated. But if I include some form of variable that's too large for that stack, then I can end up actually pushing past its boundaries and executing arbitrary code on my machine, which might be kind of useful. So I actually am not super familiar with stack smashing. How to? Gotta love the internet. So we're gonna kind of
Stack buffer overflow?
yeah, we're gonna take a look at this. Stack smashing detected, terminated. That's a good idea. Excuse me. So let's see. What we can try and do here, assuming that there's no kind of safety protections on it, we can try and stack smash a little bit. So let's up our piped out code. Let's go nano this to something like, I don't know, what's a ridiculously high number?
What's the upper limit of a 32-bit integer?
This is a megabyte of integers, which I think is larger than a reasonable stack. But we'll go to a gigabyte and let that wreak its havoc.
Let that steam up a little bit.
Yeah. So let's see what happens if we throw that. Oh, oops, not through there. Memory error. Oh, right, because this device doesn't have that much memory. Whoops, forgot about that. Sorry. We'll go 1 megabyte then. Broken pipe. Interesting. Oh, right. I always forget to give it like the index. Still a broken pipe though, because it's literally just too much.
Because the index comes before the string.
Yep. So we should be able to. Oh, right. So here's where we get kind of an interesting error. So it ran correctly, except our uppercase string is a string literal. So what I want this to do is this. We'll put this into a file. File.txt. Shocker. And if we cat file.txt, you'll see that we get a megabyte of Cs.
Yeah.
So as Andrej points out, the default stack size on Linux is 8 megabytes. I believe that is still correct on this one. This device is no different, as far as I know.
Blau Elf had asked, can we have the index be negative and somehow point to the input string? But we saw, right, that it tested for negative.
It doesn't. Well, so it doesn't check for negatives, but I don't believe we can actually have it parse a negative. Although we can try. I'm always happy to try. I always forget the dang
the first
index.
Yeah.
Oh, interesting. So it might not take it. Oh, because it takes it as an argument. Okay, sure. So we'll just do this. I just didn't think. I just assumed it was taking it from standard in. Oh, whoops. That's not right. Argument list is too long. Really? Is it? that should actually just be a bash variable. Okay, well, we can figure that out as we go. But as was pointed out, the default, oh, that's very fun. Find what file the code of the function is located at with previous exploit. Yes, we actually do know the code of the function. That one's not necessarily our issue. So let's go take a look at it and see if maybe our buffer overflow, stack smashing attacks are maybe not quite right. Oh, whoops. Because I believe Colton might have been onto something there. I thought it was the right idea, but maybe not. We'll investigate a little bit more. Okay, so here's all of our stuff. We have a type def of things. Two upper. Well, yeah, actually, let's take a look at how some of these two upper things work. So they just iterate through all of the strings, which we could truncate those by providing our own null bytes, but that's not necessarily super helpful to us. And that just says while stir at I is something. So that's not super helpful. This does the same thing, but it does 2 lower. This does 2 upper on stir at 0, but nothing else interesting really happens here. Yeah, I really do think it's a buffer overflow attack, but we need to figure out how to do it. Because it's kind of set up perfectly, right? You have old deprecated code, supposedly. We know its address. We can find it with GDB. We should have the ability to overrun this buffer somehow. We just need to figure out how to do that.
Is this meant more for beginners too, or is this kind of like a?
Yeah.
Okay.
It is kind of. I mean, at this point, you're on level 3 or so. You're about halfway through. It should be about right. It's this is definitely a reasonable difficulty.
I was gonna say the red herring philosophy might have been more for a more advanced, they try to make you think that it's something somewhat semi-obvious.
Yeah.
In this case, because it's set up so perfectly and it is beginner-oriented, it does seem like
it seems like it's probably about right. They are trying to kind of lead us that way, it looks like. And I'm not necessarily aware of how to go against what looks like correctly set up buffering. I'm sure my systems professor is shaking his head. He's turning over right now in his classroom, just oh, you should know this.
So degree instantly revoked.
Yes, you just failed my class. Yeah, mostly kidding, but I'm sure my systems professor is not happy that I'm not remembering how to do this correctly. So let's see a how-to, and we'll go and figure that out. Exploring adjacent memory against stern copy. That's kind of fun. Okay, so this is a full paper. Yeah, but null termination is not our problem here. They do null terminate their array. Unless I'm missing something in terms of what they use. Nope, those are all reasonable. Good to know. Oh, these are all just, nope, that's not what I need. Well, maybe. Okay, so what they're saying is that if the buffer is not filled completely, null bytes will be concatenated. Oh, that is a good point. Is actually if we pass in a string that is actually too small, so the opposite of a overflow, but rather we just put in something that is too tiny, then it will copy in that string. So that string will already be null terminated. No, that's not super useful. Because I was going to say we could actually get it to have a blank space in the middle where things go. But so fit Teslov is asking, run is an arbitrary function and only serves as an authenticator of a task you haven't completed. What else is called in the function calling run? Nothing actually calls run. So run is a deprecated function that is no longer used. No function in this system calls it, I believe. So run is something that we're trying to get access to and execute ourselves by taking its stack address and saying, hey, actually return this stack address instead of your return, and have that be called arbitrarily. And then from there, whatever is in buff at that moment will then get executed. So basically, we could put in an arbitrary set of bytes, like date with a null byte, and then when that gets passed in, it will call system on that, is what we're attempting to have done here. The part that we are currently stuck on and kind of thinking through is, okay, so we know that we want system to call some arbitrary function that we've named. We named it hehe, like H-E-H-E. And we want that to be called by system. Now, given that, we want to say, okay, from here, we need to get this run function to be executed or called. And so we looked through GDB at the bytecode, or the, what do you call it? The assembly of this executable. And looking through that, we found the address for run. So we now know where we want this return to be. And we know, too, that this buffer is only 64 bytes. So if we can overwrite this buffer and then overwrite the return address of this command, which is just several instructions down, then we can overwrite it with the calling address of run, and we know that at this point here, sorry, hard to highlight, right around here, we know that buff is now in the RDI register, since it is the first argument to whatever this function that's being called is. So the assembly will have buff in RDI, and since it's already in RDI, if we call run now, RDI will then be this stir here, and that'll be what system is called on, and that'll get returned to us.
What's the difference between run? How far away in instructions is run from all the other the instructions directly above it?
We can take a look. So if we go into
value
GDB, file levels / level 03, and we'll just do like a layout next. There are all shortcuts for these. So you'll notice that in truncate and call, this is all sorts of things. And as Bob Ignite suggests, do we have write permission? Nope. We don't get to write any of the executable files. We can kind of write our own executables to be used by them, but we can't edit level 03 itself. That would kind of defeat the purpose and make it a little too easy. So we're trying to think more like attackers, which is kind of like, how do we, use the tools that are given to us that are intended the right way and use them incorrectly. So if we kind of keep scrolling up, here's run, and then length is the one directly above it. And so you'll notice that basically we just want to be able to get this instruction to be executed. And what is instead happening here is in the assembly, we are running through all of these instructions, blah, blah, blah. We're calling something here. And by the end, excuse me, we jump to here. So we want to replace that with the return address for the previous instruction.
And Blauwolf mentions it too, but is there an opportunity to use a negative index?
We can try. It shouldn't actually parse correctly, I don't think, but maybe it does. So we'll try -1, and hello is our string. It executed, but nothing meaningful
Nothing
happened.
printed out.
Interesting. Good point. So let's go take a look at the source code and see.
So is it only checking for greater than or equal to the number of functions?
That is true. I wonder what a to I of negative number. Because I actually don't know exactly what a to I does. Oh, that's not useful. Okay. So let's man a to I. And this gives us some string, and the return of a to I is some integer. Seems like it would convert it correctly. Seems good to me. And then if we look in the actual function call, you're right, it actually only does check for some positive integer.
Yeah.
Except we don't necessarily know what that ends up doing. That should be some form of undefined behavior, actually. And I believe if you pass in -1 as an index, it should just actually go the other direction, as far as I'm aware. Indexing basically meaning just adding to the address of whatever you're indexing into.
Yeah.
So if we go backward and try to call,
because that's
a good point.
Because the location of whatever the
you.
first function in functions is, which is what? Where are the functions defined?
Yeah, so FNS is defined here.
So 2upper is the first function.
I
so
see.
The bytes
So
to
what
the
you're
left of
saying is
2upper
like, if we could just have it go backwards enough bytes
to get to the run function address.
Yeah, seems good to me. Huh. Very
try
cool.
it. Let's see.
All right, so we'll try that. And then we can just get it to execute arbitrary code.
That'd be cool.
So, I mean, a simple way to do this would be to just test it with every single one until it works. Like you just like arbitrarily, oh, you do eventually segfault, but maybe you don't segfault for every byte that you go back.
Yeah, because
we might want to actually calculate how many bytes this would take.
It might need to be like specific offsets.
Yeah.
Because it worked with negative
there you
1.
go.
And see
There are certain ones that this should work in. All right, very nice idea. All right, so let's go ahead and check this out. Level 03, and then layout next. All right, so let's see where FNS is sitting. Oh, we need to figure out where. If we look at what's in the RDI pointer, oh man. It's really annoying to have to keep switching between things.
Yeah, it's like having screen.
I love screen. Okay, so if we look at when truncate and call is called, FNS. Wait, let's actually see where it's using the index. So index actually just gets passed through for negative numbers. It gets called on FNS, which is in RDI. At truncate and call. So here's the actual pointer, which is in RDI. And it actually only gets called here.
Yep.
Okay.
So it's, yeah.
So as fun as it would be, I think, to go through this and like double check things, I am very tempted to just brute force it because it's some finite number of bytes
That's what
back.
Fitoslev just suggested,
Yeah.
actually.
I was going to say, I'm going to just do it that way instead of like trying to calculate it and figure it out. So let's actually set everything up correctly though. So we're going to export path to be kind of the same trick that we did before where we set it to be PWD and then the path before. And now if we just double check that that actually worked, we have our kind of scratch directory on here. We have hehe, which will print out hello. And then what we can do is kind of just like, wow, oh my God. Or actually for I in, we'll say like 1, let's try 100 to start. Do levels slash level 03 negative $I. I guess this one we just want it to be and then any other string.
Well, don't
works.
we want to pass the string that's the path to the file?
Well, right. So we actually are just executing a command, right? So we want it to execute whatever, because it does that system call again, if you'll notice up here. So it returns whatever the result of system is. So we really just want system to be called. And it's kind of the same exploit as what we had in the first function, where we wrote some function that is then executed by system. And so now hehe is in our path, so that's what will be here.
Oh, is
is
hehe running the?
Yeah, so execute, hehe will actually execute this correctly.
Okay.
Oops, and then done. Oops, where is my, oh, whoops. Yeah, so this should execute things correctly. Eventually it'll print out a hello, just because that's what hehe does currently, but we can modify that at will once we know which one it prints at. And we're gonna just...
Also print I, so you know which one.
Yeah, we're gonna ignore segmentation faults.
Oh, right, okay.
Cool. So none of them actually printed there, but we'll also just kind of keep going from there. Let's verify that this actually does what we think it does.
Yeah, because didn't we sometimes get the result printed? Like for number
well, sometimes it just did nothing.
So -1 printed hello, though.
It doesn't print anything. -1 prints zip. So if we do like /levels /level 03, -1 hello, nothing actually gets printed.
Okay,
yeah. So as long as nothing gets printed, we're fine. We're segmenting out segmentation. And then we're going to just run this through like a reasonable number of bytes. And one of these should be hello, ideally. And we'll kind of keep going.
Do you want to write? Okay.
Good point.
I was going to say. 2 to the 32.
Yeah, we could certainly try that. So although we'll run from 4096 upward. I believe that should be fine. Because basically, let's think. Because it goes backward by bytes. Oh, here, let me pull up the code itself. So from here, So I feel like we probably should have hit it by now.
Yeah.
So what it does is it says,
Oh,
okay,
right, yeah,
what is
obviously
the pointer at
Well,
FNS?
Can't we figure it out? Can we go look at the binary and look at how many?
Yeah, we can go back.
Yeah, we can just figure out how many
Instructions.
bytes are up above, right?
Yep. Sounds good to me. Level 03. So then the thing that is going to be a little bit tricky is we need to figure out where exactly the function or FNS is that variable.
Yeah.
So we do need to know where that is and what its address is. So basically,
Will that show up in?
not named, no.
okay.
But you can see here where it calls truncate and call.
Oh, I see.
You can kind of see where it would have called. Sorry, not truncate and call. Although truncate and call would be.
Truncate
fine.
and call will receive it as its.
Yeah. God, I hate having to switch between these.
It was the first argument to truncate and call. The pointer.
Right. So we want to look at what's in RDI when truncate and call. Oh, whoops, no. .c. There we go. We want to see what the what do you call it?
Already has a register.
Yeah,
Is that
RDI is your first arguments register.
Okay.
And so we want to go find where that is. So basically, when truncate and call is called, at the very end, it returns this function called on some buffer, right?
Mm-hmm.
And what we want to do is see where FNS is. So actually what we could do is go find truncate and call, look at where RDI is used, and just kind of track where that gets used to see where it ends up, what it ends up being as a value. Alternatively, in main, we can look at where truncate and call is called and see what thing is passed in as RDI.
Right.
And I think both would work. So let's go ahead and do that one.
The latter
actually.
sounds
Louder is a
easier.
little bit easier, yeah. All right, so let's go through main, and let's find where truncate and call is called. So it should be at the end here,
Yeah.
somewhere. Here,
Yeah,
here
right
it is.
there.
All right, so now let's go and look at what's in RDI. So there's a bunch of stuff in the AX, which is the return address, and we want whatever's in RDI. Let me know if you see it. They may not mess with it a whole lot because FNS is set up at the beginning. And right, so notice how there's these 4 things that are set up here, kind of randomly. So it looks like wherever ESP is the actual FNS. Because what this looks like is what they're doing is they're putting each of these addresses into the corresponding area of ESP. And so my guess...
ESP is the stack pointer, right?
It should be, yeah.
Okay.
So they're just allocating a space on the stack at the very end for this array. And what they're doing is shoving in these addresses. So my guess is if we went to this address, we would have the, I think, lower function. So let's go ahead and double check that just to make sure we're right. So this is 804.85E4. So 804.8 is going to always be true. 5E4 is the one we're looking for. And I can't scroll super quickly, but it'll pass. Don't worry.
It's a lot of bytes.
Yeah. And we want to say 5E4 should be the first byte for 2 upper. Oh, okay. Perfect.
It's the well, it's not the first byte. It's
this is the.
Oh, it is. Sorry, I was misreading.
So this one is pretty much exactly what we wanted. Or sorry, this is 2 upper. So I guess 0 is 2 upper, not 2 lower. And so we know that that is the item that is being pushed there. So we know the address of FNS. Oh, we have to scroll all the way back down now. Unfortunate. And so to clarify what we're looking for and what we're trying to do here, we're basically trying to, because of the way that arrays work in C, is C arrays say, okay, I have some address of the actual array. And if I index into some address, then what that actually syntactically does is it says, hey, take that number multiply it by the size of whatever this array contains, and then add that to the address. So if I have a series of it's an array of integers, then my array is actually just a pointer to a block of memory that contains continuous integers. So I can access any of those integers by doing whatever index you pass me multiplied by the size of an integer, which standard int is just 4 bytes. So that means that I'm going to just jump 4 bytes every time.
Oh, should we have kept our loop in increments of 4 then? Would that have been more sound?
Well, so in this case, the size of a pointer is 8 bytes. And so that's what it contains at the moment, right? So we're actually jumping by blocks of 8 bytes when we have our kind of -1, -2, and so on. And so we are basically hoping that the address of FNS
right, because it's
it's
dealing in pointer arithmetic, where the ones are the index -1 is the size of the pointer.
Yeah. So wherever FNS is, we're basically hopping backward by chunks of 8, and we're hoping that one of those chunks of 8 hits the kind of first address, the starting address of run. So we're doing kind of a weird, not a buffer overflow so much as kind of like a buffer ignorance, and moving on. Right, so what we're trying to do is get, if you look in the code here, we are essentially attempting to get this code right here. FNS is a array containing a bunch of addresses to different functions. We're trying to get the address of, we're trying to get that to actually be the address for run, and then it will be called on buffer. And that's what that syntax kind of ends up saying. And so we kind of figured we could brute force it by just passing it varying amounts of this. Although I'm starting to think that maybe we have to do something slightly more complex.
They're really making us dive deep for a level 3 challenge.
It is kind of rough challenge. So Teslov, sorry, I'm going to mispronounce your names a lot, says you can cause an exception in the script and then trace to where the pointer is. Yeah, that would work. I don't necessarily know. I think it's a little tricky to cause a specific exception and then trace to where that pointer is. I'm more comfortable looking through GDB and just kind of scrolling through it and figuring out where things are. But yeah, I think that in concept that seems reasonable, but I think this is a more kind of programmatic approach in that it will guarantee that eventually I can find a solution. And so what we're trying to do here is we're trying to say, okay, well, where is FNS located? And then where is the address for run? And can we just get FNS's value to be that address?
Right. Or at least the index at FNS.
Yeah, we just want, basically, wherever FNS is, we want the offset of like -i times 8 to go back to wherever the address of run is, to give us that address, to be that address. As people have kind of pointed out in the comments above, the array access includes a dereference, so we need a pointer to the function, not the function itself, and I agree. So brute forcing it should, in concept, work. It just may take a while. But I'm okay with a while as we kind of discuss what's going on. So I'm going to keep running this as we go, and we'll start it at 4096 and go up to, let's see, 65536. Eventually it'll reach an out-of-memory thing, and it'll freak out really hard. But yeah, so as that runs, what we're essentially trying to do is get what's called undefined behavior to execute. And a lot of privilege escalation deals with that sort of thing and or finding things that you shouldn't have access to. So what's really going on here is we're eventually, after we can figure out which oh, well, yeah, I realized your comment from like 20 minutes ago was like also print out I. That is a great point. Yes, I should have printed out I. We'll kind of ballpark it based on how long this
takes.
takes.
Okay, I mean, if nothing happens, it doesn't matter.
Right, if nothing happens, then it won't make a difference, and we'll have to kind of rethink our drawing board. Because it might be something slightly more complex, where, for example, we actually have FNS points to a function that like gets called just before, and then try to like buffer overflow from there, right? Like you can get like halfway back through truncate and call, and then instead of having the like safety measures that they have, you could arbitrarily replace things and then replace from there. That may be slightly too complex for a level 3.
I feel like that's, yeah.
But but we could, in concept, do it. And so Blauelf says, I still think we should put the pointer into the second argument and try hitting that one, unless you already have a pointer to run. And so what we're actually, the reason that the second argument is what it is at the moment is that we're eventually trying to, we're trying to get, what do you call it? We're trying to get run to use the second argument, that buffer, that string, to be what is the argument for system. So if you look back in the code, and we'll have to rethink our strategy a little bit here, but I think we're on a better track in this case. If you look in the code for run, you'll see that system is the thing that actually gets called here. And so system is called on whatever the first argument to run is, and the first argument to run will be whatever's in the RDI register when it gets called. And what we're saying is, okay, in truncate and call, you return this FNS of index called on buffer, and so buff is what's in RDI, and buff is whatever we gave it as the second argument to the function. So I want that buff to be what I want system to call, and that's what is going on here. But from there, I want the concept that we were kind of testing was, okay, let's take index and have that point us to the address of run, which will then get called on buffer. Unfortunately, that didn't seem to work. We passed in a fairly large number of attempts for I. The issue may be a kind of result of the fact that I is actually increments of 8 bytes, since the size of a pointer is 8 bytes, which is not super great for us, because that means we're not necessarily hitting every single chunk of code. And there may be another case in which we have to figure this out.
What is hehe again?
Hehe is just a script that prints out hello.
Okay.
Yeah, and eventually we could just replace it to have it print out whatever we want. And so, I mean, the reason I use that is because it's easy for me to pick out in a lot of output. Whereas like a random string, I might not notice, which is what their passwords are. So
it's just cat hello? Or
yeah,
whatever?
it just echoes it.
I
Yeah.
got it.
So if system were called on it, it would cat out hello. I did realize that we might still segfault even with the correct thing printed out. So I'm going to run this again.
And let's actually, let's get the
and we're going to stop grepping for it. But yeah, we'll print out I as well. So that does that, and then we'll echo.
Clue, try use hehe to print hello world, says Fitislav.
Equivalent, technically, to what we're doing. But I'm also not going to grep out segmentation. I'm going to grep for hello. And that should be fairly reasonable for us. Actually,
but it's not printing I either, yeah.
Yeah, I was going to say it should actually be printing I. So let's take a look. Oh, okay. Well, we can actually just have this print out, because at least it shows something changing. And let me know if you see a hello anywhere.
It's going to happen way too fast. I feel like I've seen a bunch of blips gone by that I can't really see.
Yeah, it's cruising through. Fitseslav says this is a joke. Yes, I agree. All right, and as we go through all of these numbers, there are some blips, but it doesn't seem to be finding anything particularly interesting for us. So what might be kind of use to us to note is that -1 and -8 did not have segfaults. They were actually both valid. So that might be something worth us kind of playing around with, is there are some values here that do not segfault, although most of these have.
I don't know how we could possibly see it, though. It's going so fast. I feel like we'd miss it if it were...
I think it would be a pretty solid
What if we pipe it to a file and then grep the file?
Yeah, that would work.
Can you do that?
We can also do that.
It won't be able to possibly grep through all of this at this point.
So what we can do here is actually just put this into
Bavik said the same thing, yeah. Output so far.
Oh, yeah.
I feel like it's also maybe moving faster. Oh, wait, is this just backgrounded?
Yeah, I backgrounded it, but I kind of just like figured I would background it. I forgot to make sure that its standard error also went to the file. So this is only putting out its standard out, which is annoying. And I could kill it by typing, yeah, well, I can't type fast enough, actually, to, oh, well, it's continuing to go. That's cool. I think it just recycled.
It kind of looked like it did. Wait, you didn't restart it? It just looped back to
No,
zero?
I think it looped back. So we're gonna just kill that process externally. A fun idea. We might just kill that user. Let's see. That user should have been at the bottom. Oh, that's because it got cut off. So this is level 03. I don't want to kill their PTS, but I do want to kill their other process.
All of this is using exploits to finish writing a script that solves another level script.
Yeah, pretty much.
You hacked yourself out.
Yep.
Says yes, OP.
Yep, that sounds about right. Right, I do need the password. Cat, oh right, I need level 3's password. All right, well we're gonna just cat that out to ourselves. There's level 3's password. Thanks. And then we'll switch over to level 3.
The classic cheat codes. Time stone says hello everyone. Hello, time stone.
Gotta love some cheat codes. All right, cool. And we stopped accidentally blasting ourselves with level 3 output. Okay, so we're gonna kind of to recap. So we have levels, level 03, and what this takes is some indices, which indexes into a list of functions, function pointers actually, and it then tries to call them. So unfortunately, we are not doing that quite correctly, and I don't know that I think our negative indexing is right in terms of ideas, but it's not quite what we're going for here. So there is some other kind of trick to this, or some misunderstanding that I'm making. But you'll notice that -1 actually doesn't segfault, and have it as -8.
Does -16?
We'll try it. Yep.
Okay, so it's not deterministic on any sort of pattern.
No.
Well, maybe not a pattern that we recognize.
Not a pattern that we see.
It had printed there though. Okay.
Oh,
no,
so
that's
yeah,
part of the
that's
command.
just
It's
it's
part of the
wrapping.
command.
Yeah. And if we did like a 32 or something, still segfaults. So 1 and 8 don't though. And I think that's kind of interesting. So if we look back at, or we'll do
Does it
less.
have anything to do with that instruction? Like, are 1 and 8 the same instruction? That
It
offset?
might. So let's see.
And also, see you, Martin. Thanks for popping by. Appreciate it.
Yeah, bye. All right. So if we look, whoa. Let's just take a look. Make sure I'm not missing anything there. Where is FN's defined? Right. So FN pointer. Oh, also, I didn't realize FN pointer is a custom type. Let's go take a look at FN pointer. So FN pointer star, oh boy, is defined as, so the dereferencing of FN pointer, which is an address. Okay, so it's still an address, which doesn't help us too much, but is a constant char star. Oh, okay. So they just put it into like the discrete byte units, and then they defined it as an int. That's cool. Okay. Coolio. So what we want to do is we're basically trying to replace this index with something that allows us to access something interesting. But wherever FNS is, apparently 1 address back is kind of interesting. It doesn't segfault at all. And then 8 addresses back also doesn't segfault, which is very strange.
Wait, they're type defing int throughout the whole program?
No, sorry. So type def is weird because it's backwards. So the
type defing.
Yeah. So if you dereference FN pointer and call it on constant char star, that type def is of an int.
Oh, I see.
And I guess that works to implicitly define FN pointer, which is, I didn't know that that's how that worked, but that's what that reads to me. And yeah, type defs are backwards. So type def int, whatever follows that is now defined as an int. It's very irritating. Okay, so we have come to kind of a couple of ideas. So Bob Ignite suggests, hey, maybe it's a cubic pattern. Sounds good to me. Let's see if maybe that's true. 27? Nope, sorry. But what we're going to try and do is see if we can figure out what kind of idea we're missing here. It seems like there's some other stuff going on. So we know that we can access 2 addresses, 1 back and 8 back, and they don't segfault. They're not broken, which is very strange, but seems fine. And we know that they buffer overflow protect as much as they could have. They follow the instructions that we found on Stack Overflow and the internet. So it's probably not a direct buffer overflow, but there might be something kind of interesting going on here. Now my guess is that wherever this is currently located, FNS is on the stack, and if we go one address back, what we can do is we're calling something. We're doing something that's valid. So wherever FNS is, one address size back is okay. It's valid. 8 is also valid, meaning that one of those two is probably useful to us, assuming that this negative indexing is doing what we want it to do.
Right.
So if we look at where FNS is here, one address back would probably be something like this, and 8 addresses back is probably the actual function itself. Although, if that were true, then it should end up getting called over and over and over again and eventually just running out of memory. Like it should just recursively call itself. So that can't be true. So my next approach or kind of idea might be, okay, in this case, what should I look at? And I would say something like GDB, right? And so let's go back into GDB and see if we can figure that one out.
Late happy birthday, Colton. Thank you, Timestone. It's getting late in Egypt, so thanks so much for the lecture, Colton and Nick. Awesome. Well, thanks for tuning by.
Thank you
very much for the kind message. Appreciate it. And then Fitnesslab was saying that this is computer abuse. To solve this, you'll need to use a bunch of parts of scripts to rewrite its own script. Maybe the solution ultimately is to hit a CPU range percentage?
I don't think so. There aren't too many exploits that I know of that aren't like of some form of like super fun and advanced that would hit a CPU range. Certainly not a level 3 on a beginner CTF. But also I don't necessarily see how hitting a certain CPU range would help us here. I believe we're on the right track in terms of some form of dealing with either bad indexing or buffer overflows. They both deal with undefined behavior. And so what this exploit and or level is really touching on is how can you get code to execute, how you can get C code to execute undefined behavior in a meaningful way. And so, yeah, what we're looking for is where FNS actually sits, or functions actually sits. And what we can do is we can see in truncate and call, it eventually calls, let's see. It jumps if equal to, if the equal flag is set. We want to see where, okay, so here's where stern copy is called, which is right here, line 50 in truncating call, or instruction at line 50, byte 50, sorry. And then we kind of like move some stuff. We do some kind of shifts, adding and moving, load effective address. Oh, so here's where we're actually loading an effective address into our return. And then we're going to call the dereference of EDX, which is just part of the RAX register. So, or sorry, that's not true. It's part of a different register. It's half. So EAX is half of the RAX register. And then it looks like we load 0, or this address backward into EDX, and from there we say if everything is valid, then jump, otherwise don't, like, fail. Basically just give up and say that there was some real problem. Okay, so basically what we're trying to do is get this kind of, let me highlight the instructions that are important to us. We're trying to get this to load in the address of something that doesn't belong. We're trying to get it to load in the address of run. Now we know the address of run, but we don't necessarily, we haven't quite figured out how to get it to do anything meaningful yet. We haven't quite figured that one out. So we are now left in the place where it's like we have to kind of just guess and debug and take cracks at things. So we tried a buffer overflow, but we know that that one doesn't work. We think that it doesn't work. We looked at some stack smashing, but we're pretty sure that that's not quite what they were pointing us at. And then we're at this point where we realize that negative indexes are valid sometimes, and we're not quite sure where we want to go from there. So let's take a look at what like -1 might look like. So if we load in -1, which is probably coming from EVP, I think, is part of the second instruction or second pointer. But let me double check that. Let's see, RDI, argument order pointer registers. I don't always remember these. I would if I was still doing these actively. Where are my favorite registers? Oh, sad. I know it's like RDI, RSI, RDX, right? And RSI is the second argument. Okay.
Trebinator says greetings from Germany.
Hey.
Hello, Trebinator.
I unfortunately do not speak any German, but hello.
Greetings from the United States.
Yeah, welcome. Okay, so if we look back to where FNS sits on the stack, actually we don't know where FNS sits on the stack. We should probably go find that. I realized that I don't know FNS's actual address.
Yeah, I think we were
thinking about going and finding that. Yeah, let's go ahead and do that. So this moves. Okay. So here's its address is at ESP. Move ESP into EVP and do a logical AND of these two, and then subtract 30. Oh, right, but we're in hexadecimal, so that's what, 48 bytes?
I don't know. I don't know my hex offhand. My hex.
We can. Oh, whoops. We can convert. What's 0x30? And also,
I know like that is 48. Yeah.
I think that's 48. Oh wait, I also forgot I had Google. 0x30. Yeah. Okay.
Yeah.
I'm sure someone will leave a comment like, "Oh, you can't do hexadecimal in your head." And it's like, "Yep, that's correct. You're right."
I guess it's like 16 times 3
yeah,
in that
it
case,
should have
but
been.
it gets harder when
it does
has,
get somewhat trickier, and also I'm not the best at computationally like mental math. Never really needed to be. Okay, so we know that it puts the addresses for our 4 functions into the varying offsets of ESP, and we also know that we subtract 30 from ESP. So that gives us space for 4 addresses, which makes sense. So each address is apparently 16, and we're adding. Oh, well, actually, yeah, that makes perfect sense. And then we're roughly just all F's and then a 0 is that the max space for that? Like 1, 2, 3, 4, 5, 6, 7. Yeah, okay. Excuse me. All F's is the all ones. All F's and a 0 means your last, 2? Or your last 1 is a 0? I don't know. We'll find out. So from here, we basically want to say what? Where do we want to mess with things?
I feel like this is getting so complex for a level 3.
I know, but and I feel like the answer should be staring us right in the face.
It'd be really funny if this was just like some really obvious
like some
problem,
simple,
and we just like went straight for like the really hard stuff.
All right, well, in that case, let's step back and think about it for a sec. That's a good point, that we are in some somewhat complex territory. They're definitely within bounds, but maybe in the upper bound. Let's take a look again at what we know. So level 3, right, can't do that.
Like from PHP to like digging down into the assembly
GDB,
of
it's a little much. Okay, so we know that level 03 takes in some index and some string, and from there it executes in some way. Now, if we go and cat out what each of the source code files say, or sorry, I don't really want to use cat. I want to use less.
Is there an opportunity to use non-ASCII, like not non-ASCII symbols, but non-alphanumeric symbols to do anything?
We could write raw bytes or kind of non-numeric things or non-ASCII things to it. We can write raw bytes.
Because 2 upper is probably safe on non-alphanumeric.
Yeah, so let's take a look at kind of things that are going on here. So 2 upper is pretty reasonable. Yeah. And then 2 lower is also quite reasonable. Seems fine. And then put char of 2 upper. Oh, okay, so this one just assumes the first thing, 2 upper of it, and then put char of 2 lower of the rest of them. Okay. And then length just iterates through, increments its length, and then prints that out to us. So none of the other functions seem inherently terrible.
Flawed, yeah.
And none of them really have arrays or things that we can really interact with anywhere meaningfully. So let's take a look at how, well, so run just calls system. So we know run is the objective in some way.
Right.
That has to be what we're going for, is somehow we want to execute run. And then from here, we know truncating call gets called at the end of main. And it takes in this pointer to, or sorry, an array of functions. And then index, which is just some number. And then it takes in this like string, which is the user supplied string. It allocates a char buffer of size 64, so 64 bytes, and it copies in 63 bytes from the user string up to the size of buffer minus 1. So that's how we knew it was 63.
What's the size of num functions, the constant?
Where?
Num funds? The constant
this,
that's in
4.
Is it
so that is the number 4.
It's defined at 4 up top?
Yeah, it's hash defined as 4.
Okay. That'd be funny if it was like 5.
It's like 20, yeah. Yeah. And from here, we are basically assuming that you're supposed to use 0, 1, 2, and 3 to access the appropriate numbers. And we know that if you pass it an index that is too large, it catches that and says no before it ever tries to access it. So those ones not necessarily super helpful to us. So from there,
The only flaw so far is that it doesn't check for negative numbers
yep,
that I've seen.
that's the only one I can see either, or as well, is that negative numbers are not checked, and argv2 is always set correct, is passed in directly. So they don't validate anything about your second argument. So really what we're trying to look for here is how do we get run to execute? And my guess is that the negative numbers intuition is roughly right. The problem I have, I guess, is that it's not quite there, right? Like it's like almost, but we tried brute forcing it within reason. And
Is there something flawed
not
at
quite
all
there.
with what we're printing, or how we're actually like running that loop?
could be, yeah. So let me just double check that it's executing what we think it is. So let's do levels/level 03. We'll do negative, I guess 2 or 1, which should print out nothing, and this. Yep, no seg fault. So that's the right kind of idea, and then what we'll do is we'll export I equals 1, and then we'll do a bash complete or bash substitution I. Oh, whoops. Weird that uppercased it though.
Wait, what did you type in? What's the index?
I didn't type in anything. I actually just accidentally placed parentheses around something that shouldn't have been placed.
Wait, what
That was very strange. Oh, I guess because the return code of that is 0, and -0 is still 0.
Oh, sure. Okay.
So 0 works.
Bob was saying, still believe we should have the pointer in the string. Maybe we don't need the full 63 characters.
So if we were to put the pointer in the string, I'll walk through it, I guess, to kind of debunk why I don't think that would be necessary. Is let's say we put the pointer into the string, then essentially what you're doing is you're saying, okay, we're going to copy over that pointer into buff. And the pointer is not more than 63 bytes, so we don't have to worry about that. It'll get put in there. And then once we have our pointer in buff, that is just a string. So the data is still being treated as a string, and then whatever index you pass will be called, that function will be called with that string pointer as its argument. So for example, I can pass in a random pointer that is roughly right. So we'll do like a 0x, 0. This wouldn't actually be quite right because it is represented as ASCII, but we could print it as binary and it wouldn't actually matter. But if we do 0x00, we'll just get the x capitalized. And if I were to pass in just raw data, we also really shouldn't get too many interesting things happening. To pass in raw data that would look like a pointer. It actually doesn't matter. Either way, it's being treated as a string. So we don't really want that, but we do want to call a function arbitrarily. And the function that we want to call is run. And actually, as many of you have suggested, the why is run deprecated, we actually don't necessarily care too much about why it was deprecated. As much as that is part of the story of the CTF, it doesn't really deal with how we could use it. So the reasoning behind why a function is deprecated doesn't necessarily matter to us since it's still there. I can still access it in the bytecode, and that means that I could still arbitrarily execute it. What could be useful is to have this execute in main and have it just call that. Oh, no. I was going to say, if I could just arbitrarily execute parts of this code, that would be very useful as well. To just execute run from the bytecode. But I don't believe I can do that. This would be, I think, too advanced, but you could grab its assembly and execute that, possibly. But again, it would be created with the wrong permissions, so actually never mind.
What happens if you overflow the buffer? Sorry, I came here really late, says irene.
So irene says, what happens if you overflow the buffer? We actually can't in this case. It appears that they use this correctly. It will only copy up to 63 bytes from our input string into the buffer, and that's unfortunately not going to let us overflow it. They also remembered to null terminate their buffer, which is apparently the common problem with stern copy. So it doesn't seem to have a obvious buffer overflow opportunity. There is the possibility that this is a stack smashing kind of attack, but I don't think that that would be particularly useful here. What we did discover was that negative indexes are sometimes valid. Not often, but sometimes. There is the occasional index where the negative index is valid. And what we're about to try is actually just putting that into a while loop and executing the ones that this is valid. Telling us which ones it's valid. So if we echo $i, so what I want to do is this. So while, or not while, for I in 1 to, we'll say 8, because we know some of those are valid. Do this, which just executes this with that %i, and then echo $i. I said %i, I meant $.
And you want to pipe this to a file?
Yeah, and we'll just shove that. Oops, sorry, done. We'll shove both of those into our data.txt.
Standard out and standard error?
Yeah, because the standard error will be the segmentation faults. Well, or not.
So we got 6, so that's appropriate though, because 1 and 8.
Yeah, because 1 and 8 should have worked.
Yeah.
So actually,
but we need the numbers outputted as well.
Yeah, I realized I didn't wrap this effectively. There we go. Okay, so now if we cat data.txt, we get 1, 2, 3, 4, 5, 6, 7, 8 with no segmentation faults.
Interesting. Okay. That's supposed to be printing segmentation fault though, right?
It should, yeah. As far as I'm aware, this is the correct syntax for piping that correctly. But I might be, because I'm dropping it into a subshell as well. So maybe the subshell's version of this doesn't get piped over. You would think for someone who spends so much time with Unix systems, I would know even more. But I don't quite. Oh, also, what time is it? Yes, I will have to, unfortunately, end this fun little endeavor into this. Man, these things, they're so fun, and they're so,
time
you want to just solve them.
Doesn't it?
Yeah, that's annoying. So I'm always sad to not be able to finish a CTF, but also that would mean spending a little bit too much time. So yeah, unfortunately, we probably won't be able to get through level 03 today either. But this time it was set up correctly, and this time we actually got to spend time working on the CTF itself rather than debugging the setup and the CTF.
You're around. We can do another episode sometime.
We can do more of these as well. I do enjoy kind of bashing my head against these a little bit. I think it's worth kind of walking through how I think through it and also just kind of trying out new things. This kind of CTF I think is particularly fun and engaging because there are many different iterations of it and you can do all sorts of different kinds. If you're ever interested, there is a generator for this kind of CTF. It's called SecGen. And you can go ahead and look at their GitHub. It's pretty fun. They give you a tool that basically builds these sorts of CTFs. This one, we posted a link. We can repost that.
Yeah, can you bring that up so I can
right
type in the chat?
So there's this link, and that is the kind of tutorial that I follow to set up the CTF. It's fairly straightforward and simple. You basically just, well, go to AWS and grab an AMI for it. Fairly easy to build, pretty straightforward, not too bad. It's a fairly straightforward CTF. It's pretty much a beginner's CTF as far as this is concerned.
Although we are having a bit of a
We're
time.
having a heyday with it. And by beginner CTFs, like you should sit there and struggle through them.
It's still pretty technically challenging.
They're definitely like, there's a large, I mean, there's an almost infinite design space. There's a logistically infinite one where they can come up with all sorts of creative problems and things to solve. And the more of these that you kind of look at and try to solve, the better you get at seeing them and recognizing them in the future. And as Colton pointed out, my first approach to this looked like a buffer overflow, but that was probably not actually the right approach. And so that's a great example of where the patterns that I've seen before point me in that direction, but for someone who is maybe either has never seen that before or who knows this a lot better than I do would not immediately go there.
What should be like the simplest answer?
I would imagine by like Occam's razor's principle, or the principle of Occam's razor, we would end up at that solution. So yeah, so you're welcome to go ahead and try these on your own. Feel free to tell us how they went. Next time, I think we'll be talking about Kali Linux. We'll have an exploitable machine out on the web, and we will go through how Kali can be used to take together or take down a machine like that. I think is very fun.
And for folks who may be unfamiliar, Kali Linux featured heavily in Mr. Robot, which is a very popular show. They use it all the time. FSI uses it all the time. But yeah, thanks so much for coming on, for doing this part 2.
Thank you for having me.
It was very similar to the last one in the sense, but we also got more done the right way.
Yeah, we did it correctly this time.
It was a much more, I think, representative look at how a CTF is done legitimately.
This is much more correct. I'd say legitimately in the sense of like, we approached it right. Most people who actually do these, I think, for like real-time like competitions, they're a lot more experienced in these sorts of things, and they tend to do more of them. For this sort of thing, they would have seen it before and or be able to figure it out. For myself, it's just kind of a fun little exercise.
I think Bavik's excited to get to Kali Linux. So
yes, he's been waiting for quite some time.
Thanks, Colton and Nick. Happy 50th stream, Colton.
Happy
Thanks,
50th
Ashley.
stream.
Much appreciated. And Bavik says thank you as well. Yeah, this was episode 50. This is pretty exciting.
Yeah, that's cool.
And
glad
also,
to be able to be part of it.
the rebranding is cool too. I'm liking what I see. I like that logo a lot. I didn't create that logo. I have to shout out production for making that logo, but it's nice. It's clean and it's kind of bold too, a little bit. CS50 Live.
Looks good.
Yeah, thanks so much, everybody. This is CS50 Live, not CS50 on Twitch.
Yeah.
I mean, not exclusively anyway.
Rebranded.
You'll probably be most likely watching this live on Twitch right now. But this is CS50 Live. Join us on Friday. It'll just be me. I'll be talking about jQuery, which is a JavaScript library.
Ooh, fun.
You can just do AJAX requests. You can use it to manipulate the DOM in cool ways. You can do some animations with it. It's got a bunch of functions, and we'll take a look at a bunch of them. And then next week you're doing Kali Linux.
Yep.
And we're figuring out the rest of the schedule, but I think on Wednesday I'll be doing a text adventure, and then on Friday we'll see that we're still working on the details for. But thanks so much everybody who tuned in. This is CS50 Live, episode 50. We'll see you all on Friday. Oops, and I switched to the wrong slide. All right, have a good one. Stay safe.